All right, we are live for day 18 of Advent Code. And we are about an hour early because today what we're going to do is a bit of a recap and refactor of day 17. So let me just pull that up and remember what this is. Um, so there's a crucible that's navigating a map. And this map has there's a bunch of numbers in here. This stands for the heat loss at every point in the map. What we have to do is find a path through this that minimizes the amount of its heat loss. So this looks like a standard Dijkstra problem or A star, but there is a little bit of a twist here. So right here, when going in a straight line, it can move at most 3 blocks, and then it has to make a 90-degree turn to the left or the right. So there's a limitation on the amount of straight moves it can push. For part 2, that changes up a little bit even more. That has to go forward a minimum of 4 blocks and then a maximum of 10 consecutive blocks without turning. Right, so let's get back into that problem. Maybe I'll do a quick review of what I did yesterday. Talk about what I want to change. And then we're going to write this up. I think we're going to write this up starting again kind of from scratch. Right, so generally here, I had a state. And this covers the position, the direction you've been moving, and how long you've been moving in that straight line. So these two are kind of tied together, which when modeling a state, in exactly like the origin case, there's not actually a direction you've been moving in, right? Direction is, the straight streak would be 0. Sometimes you want to just like tie these things into their own thing. And then I also add heat model, so all the heat collected in that state at that point. And in the refactor, I think I'm going to remove this heat altogether from the model, and I'll tell you why later. But anyway, this has a single method, and that just gives us all of the possible states you can get to from here, right? Which is, first we look at the viable directions, and this is left, right, or forward, and forward depends on whether or not we have a straight streak of 3. And then we filter out with a balance check, and then we just apply, the new positions, the new straight streak, etc. And that code right there is pretty straightforward. And then our search here, it is a Dijkstra search. Oh, let me revert some of these changes to like what we actually had. Revert that. We'll revert this. Okay, so our search here is a typical Dijkstra / A star. We're using a priority queue. And then we also use a set and a map here. I don't think you need both. We can do it with one or the either. But what I'm using the set for is to keep track of all the states I've seen, and then I'm diffing by those states. So I give myself an ordering on the states so that I could use a priority queue. This bit here of the ordering is not necessary. This is a heuristic, and this underestimates. So this gives you the Manhattan distance at the end, and that underestimates what the maximum heat that thing can have is, right? And then this is the actual heat for that state or for the position. I said earlier I might take heat out of the state, and this here makes that difficult. I was thinking I might be able to use my best heat map, but we have to know what state leads to that heat, not just that point itself, because it matters, the streak you've been going once you've hit that point. I don't know. maybe this best heat is a map from state to int. But we'll think about that. That's the kind of thing we'll handle while we're refactoring this. Um, okay, and then this here is the heart of the algorithm, right? So we take our next states, that method that we defined earlier, and then we do some filters on that. And this whole thing would work without these filters. In fact, without any of these. So we'll not focus on the filters right now. You can take all these next states, and then you can enqueue these states, prop them to your priority queue, um, and then visiting becomes your next thing on your priority queue, and you keep visiting the thing with the best heat cost so far. So these filters prevent you from over searching. And the first thing I'd done was just a filter not visited. And that will work on the example. This is enough to get you the correct answer, but it's not quite performant enough. So what I'd done was also filter, like if any state exists that has a smaller straight streak, then I would use that. And if any state exists, oh hey Vivek, welcome, welcome. I appreciate it. Um, and then here, I also check the heat. So this here is a fuzzy check. I check that the best heat for that position is within 5 of the heat of this. So it turns out that there can be two states that are at the same heat where one has a better path to the end than another one. Hence this -5 in here, and this was a sort of guess and check thing. And it'll turn out that we don't need either of these filters. We can prune fairly efficiently just by um, taking 3 parts of our state, and that is the where did we go? We've gone somewhere completely differently. Um, and that is the position, direction, and a straight streak. That's all you need in order to dedupe this. So we can start with that refactor. Uh, this best heat here might still come in handy if I decide to take heat, this map, if I take heat out of the state. But we'll play around with it. Let's just revert this and see this working. 102. And just for reference here, I'm going to copy the worksheet output. And, oh no, what I want to see. So I use this print line here to count the number of states I visit. We could just put a variable here. But here, we're visiting roughly 1,000 states or 1,100 states. And this is also what I use to inform what kind of filters I add. Right? Like, do we if you do this raw, you'll see in here a lot of points that you can, maybe like many states are at the same point and some have much higher heat than the others, and then that can't possibly be the best. Hence that fuzzy search here. And then you see some cases where like 2 states manage to get to the same point. One has a lower street count, so it has more flexibility. So you prefer that too, right? And you just see duplicate states generally, and you don't want to do that because then your priority queue will grow a lot. And I think when I did that, I don't know, you can get, was it like 2,700? 27,000, many states, too many states. Okay, so I think we will do a refactor of this, but I'm just going to save this into a different file in case we want to reference what we've done previously. All right. In fact, let's start from scratch a little bit. And we'll work with this. So when I parsed this originally, I just did the vector of string. And that means now when I get a point in that grid, I have to convert that character to back to a digit. And we don't want to have to do that every time we reference it. So let's do a little bit some smarter parsing here. So to vector, we can map here. And for each string, we do s to s dot map dot as digit and two vectors. So this can be like a 2D vector. Okay, so now this is a 2D grid of vector. And I'm going to make an area. So this is my area class I use. Eventually, this will go into like a self-contained tutorial. So we're going to implement something that's lighter weight than a full-on area. But an area basically contains an X range and a Y range and gives you many convenience methods for that. So this is in my admin of code repo under point.scala currently. I'll organize that more at some point. Yeah. So let's start with a state, and let's keep this a little bit minimal. Case class, and we have a position, which is a point, which a point just contains like an X and a Y. And of course, there are all these convenience methods, not all of which we will need. So we have a position, then we have a direction that we've been moving, and then we're gonna call this like straight streak, maybe streak. That's a better name. Now, one thing I want to do, the goal here is to have this be in a lot of smaller chunks of code that are easier to digest in a tutorial, right? So one thing we'll do is this next states here, we are going to separate some of the state generation logic from this validation logic. So right now it's all tied together. And for this block of code, that seems fine. But when I extended that to part 2, day 17, part 2, let me pull that up. Oh, is this the right day 17, part 2? No. Day 17, part 2, this is 2023. Here we go. When I extended that to part 2, it did get a bit longer. There's a lot more if else checking. I don't like how this looks. So in anticipation of that, we're going to handle states separately, or handle like the smaller state transitions separately from generating all the next states that are viable. So let's start with the easiest one. If we just move forward, right? So this should give us a new state. And now we can do a copy. Copilot almost has the right idea. We're gonna say pause equals pause that move in that direction. And then we save the same direction, and then streak gets updated. So streak becomes streak plus 1. And then turn left. And let's see if it gets the idea. Yes, the direction changes. I don't want to just turn though. I want to turn left and move forward. And do that all kind of in one move. Because we want to end up in a new position. It'll be kind of a waste to analyze this. So let's say val new dir or val new pause. Let's see if it's able to figure that. So pause that move in the new direction. And now again, this direction is an enum, east, south, west, north. I've turn right, turn left, reverse defined in here. And actually that's pretty much all that's defined in here. A point can be moved by a direction. So now we say, we'll do copy. You know what, we don't, we're changing everything. So I'm just going to write a whole new point. So we have, or a whole new, not a whole new point, but a whole new state. So state, new pause, new direction, and a streak of 1, right? Um, mm, I'm thinking that can be inlined. This is probably a good candidate for inlining. We'll inline at least that line because neuter is used twice. And then turn right. It's going to be similar. Copilot can complete that. There we go. All right, and then now we can define something like next states. Uh, okay, this is almost correct. We do want to filter that the area contains our position. And in fact, I feel like I have other ways to phrase this. So s.pause.inbounds. No, I guess I don't have that method defined. Um, the straight bit is only one that needs to be filtered for the streak. Actually, this filter does catch that. But the streak should be less than or equal to 3. Right? So if we move forward 3 times, then we can't move forward a 4th time. So this filter takes that out. Okay, that is even though that's more verbose, it is easier to read than the stuff on the right, and that will scale better for part 2. So we're happy with our state. And now let's do our search. Um, Here I had various parameters, a start and an endpoint. We'll stick with those for now. In fact, you know what? We're going to copy paste a lot of this from our previous attempt. Okay, so we're going to copy paste a lot of this. We're just going to edit that a bit. And now this should still work after we fix any kind of errors that we have here. This seems to be, these aren't errors in my file. So these are errors that sometimes come up with worksheets, and I'm not sure why they appear. Right, so this doesn't work with this state because it was written for a state that also contains a heat variable. And now here's where I need to think about this a bit and think about if I can actually remove heat from our state. Let's say if I put that into I could put that into a map, but then that map is only useful for this ordering. Right, otherwise, what I would have to write this visiting state. The reason I dropped this down to 3 pieces, just those 3, is because just those 3 is sufficient to dedupe this, right? And we want to simplify this code. Like it won't prune down as many states, but it will still be enough that this runs in under a second. So we'll start writing that. Okay, so we can write like best heat per state. Let's just give that a try and see what it ends up looking like. If that doesn't work, then we can refactor this on the right. Um, yeah, so this ordering needs to appear after the map. So let's start by defining kind of the map at the top, and this will be from state to int. And then we define this map, and we need a way to compute heat. Oh, we just get it from here. So we take best best heat given that state, and we'll leave the heuristic in for now. It shouldn't be necessary. We might remove it just to simplify the code later. And then this whole thing becomes ordering by just best heat. In fact, you know what? Let's just do that right now. Ordering by best heat. And then now this ordering is used by this priority queue. And before we put anything into that priority queue, we should make sure the map, we're using mutable maps here. The priority queue itself is mutable. So we need to make sure that the values are in our map. Um, so let's say that the best heat for the point we start visiting, well, which is defined here, is 0. And we have our set of visit states, which is exactly this point that we're visiting, right? Now we can simplify this. Next states dot filter not visited, and we don't need any of this other stuff. We do still need to add the best heat. So for each best heat of that state becomes the minimum of whatever's already in there, or else the heat that we found here. And that heat actually needs to be calculated. So val heat loss, it's going to be best heat for the previous state for visiting, and then we're going to add in grid for the grid value. This grid value, I might just rename that. I'm going to call this heat loss because it is the heat loss grid specifically. So rename symbol heat loss. Okay. So best heat so far for the point that we were visiting from, and then there's this new state. We get the heat loss for the point where it is, and then we keep the best one in the map. Let's see. We'll take out this dot pause here because that's supposed to be a full state. Recursive value heat loss. Oh, we've named these the same thing. Let's just call this H here. And we could do like a min between that and H. And then what we return when we get to the end is the well, I want to do the best heat at a position. I suppose once we've reached the end, that is it. So we're going to do the best heat for visiting, and we can do val ans1 equals search from the point to origin. and then we're going for bot right. And that should be our answer, 102. Great. So let's take a look at this. I want to see how many states this generates. So we'll open up Scratch file, and this generates like 1600. But it is fast enough that works not just example, but on like a full problem. Right, 959. That's the correct answer. Great. So this works, but we do have to define a map from any state to the best heat. I'm not sure if I like this completely, right? Because the best heat loss should just be part of the state, because it inherently is, right? You move around through the map and you're losing heat. Um, so what I might do instead is just get a little function that turns this into the full state into this triple. So we're going to put heat loss back into here. Total heat loss. Yeah, we'll say total heat loss int. Okay, now if we move straight, total heat loss equals total heat loss so far plus the heat loss at this position. Direction is not changing, so this can be a copy constructor, but I think this will still read better if we just write this as a state. So pause that move in that direction, and we copy the same direction. Streak is just streak plus 1. Yeah, this reads nicer not having to say the variable names. So we'll write that instead. And then the new heat, the new total heat is going to be total heat loss plus the heat loss of the new position. So I'm going to define new position back up here. Now new pos equals pos that move and endure. And we'll use that down here. New pos and total heat loss plus the heat loss of the new position. Okay, and then similar deal here. Let's just let autocomplete do this. There we go. And total heat loss plus heat loss of the new position. Not found new pos, that needs to be capitalized. Okay. Now visiting. We want a method that turns state into the position and direction. This is still the state that we're visiting. The total heat loss is going to start at 0. And this set is now going to be a set of a triple. So I think I'll define a little method here. Def pause and direction. What's a word for that? Momentum, velocity, trajectory. Just call it like the trajectory. The trajectory. This is going to be a triple of just the pause, direction, and the streak. Right, and then now what we put in this map to dedupe, or in the set to dedupe, is just visiting that trajectory. And the filter not visit trajectories, s.trajectory. Now we don't need to put anything into this best heat map anymore because best heat is part of the state. So we'll remove this altogether. And then now we just take the state dot total heat loss of that state. Yeah, so we're ordering by total heat loss. This code becomes shorter. Visit ++ equals states dot map trajectory. There we go. And then now instead of best heat, we can say visiting dot total heat loss. We do have an out of bounds exception. -1 is out of bounds. So something here changed. Let's check our bounds check here. Right. So we have next states. We do check that all of these are in bounds. Where is that happening? Inside turn. Oh, you know what? I see exactly where it's happening here. In this heat loss calculation. So we need to filter out sooner before we move, before we calculate this heat loss. That turns these into options of states, which I'm not sure how I feel about that. That will make this code need flat maps essentially. But we can take out this filter. Okay, so we can turn this into like a flatten, right? So these are now optional states. Like turning right might not be a valid move. Sure. And in fact, all of them will be. So option dot when suppose we calculate the updated heat loss at the end. No, we're not going to do that. Because then these all have to be sort of private methods, if that's the case. Which honestly, that might be a decent option. Let's think about that. Let's start with what the refactor looks like here. So option.when area that contains new pause. Then we return to state, right? And then we have the same kind of thing here. And we had the same kind of thing here. Val new pause equals pause.move in that direction. And then we have the same option.when stuff. Okay, well, we'll do it this way for now. And then if we decide we don't want to do that, I'll think of a refactor. But now we can flatten this and take out this filter because we've already done that. And this here can now be part of the option of this straight here. So when air contains a new position and a streak, here it'd be streak is less than 3, then we're allowed to keep moving forward. In fact, we'll put that check first. There we go. So I've kind of reversed things. I said I'd want to make new states have all my validation, and this would just be like strictly a state transformation. But apparently it is kind of necessary to construct a new state if it's also going to contain the heat loss. So we can play around with that. Our answer here has changed. Let's see what we're changing here. So we still, hmm, let's see what answer it gives. It's giving an answer that's too small. So somewhere here, we're not adding the new heat loss. So this is a state with a position at the end. Let's examine this a little bit. We'll do a quick debug. Okay, so there are like 1,500 lines. That's about what we expect. Look at some early states here and see if we can notice anything fishy. Um, well, there are a bunch of points in the top left corner, like here, 0, 1 with heat of 7. That can be filtered out. I don't think that's causing us to get the wrong answer. I do think that is unnecessary, but I'm trying to keep the number of checks here minimal. So maybe we don't handle that just yet. We want something even fishier. Let's look at, say, oh, I think given the state, we want to know what we are enqueuing from there. And let's look at the next states from there. Or in fact, let's take a state, like our start state here. And let's test out some values for next states. So we're starting from point.origin, and then s.nextStates. Let's see what we get. This is reasonable. So we move to the east, and we increase our heat by 2. We move to the south, and we increase our heat by 3. Let's move south further. So let's take like s dot. I think we're starting heading east. So let's go straight. Wait. S dot straight. Yeah, that should be a function. And let's go straight again. Or we have to dot flat map straight. Might make lose heat a separate function of some sort. Or you know what? I might default to 0. You don't lose any heat if you're not even in this area, right? And then we could say like, okay, like it's sort of, you can go out of bounds, but we filtered that out. It's still a state we can generate, and it'd be easier to test. We can just say dot straight, dot straight, dot straight. Okay, so let's look at our input. So day 17, and then just dot text 2023. So 3 and then 1. If we go straight and then straight, we should add 3 and then we should add 1. Let's look at both of those. So we'll do like a straight dot get, and we'll do this flat mat, another straight and dot get. So when we move to the right, oh, when you move to the right, it should go 3, right? Oh, this is the example. This is the example. Let's pull up the example. 17 example 2023. Okay, so when we move to the right the first time, we add 4. And right now what we're getting is we're adding 2. Interesting. What is our vector printing? I think our vector might be printing the wrong thing. So we'll do like heat loss for each print line. Take a look at that. 4, 1, 3. Okay, I think what we're doing is we're not doing heat loss on the new position. There it is. There it is. When we turn left and we turn right, it's fine. When we go straight, we hadn't done that refactor. Okay, so we're back to getting 102. And for the main example, we're back to getting 959. Okay, that works. Let's move on to incorporating part 2. So turn left and turn right will still be somewhat the same, except now when we're generating our next states, whenever we turn left or turn right, we'll want to just move straight 4 times in a row, right? Which means we don't really want these to be options. So we're going to do a heat loss that get at a new position. Get or else. I think get or else is defined on maps. Oh, let's just define a heat loss function. Def heat loss, and we'll rename this to grid. So hit heat loss for some point. And then we'll check if it's in bounds. We'll put area here. And we'll do if area that contains point, then just grid of P. Otherwise 0. Okay, there we go. We can stop this from being an option. And we'll move this back out. Then it gets easier to chain. This is a choice for convenience here, for simplicity of user interface. And then we put our validation back here into next states. The next states, and then we'll do a dot filter on here, dot filter. And this here, now these here are all generic for parts 1 and 2. The rules for these, the validation for rule is changed in part 2, which is part of why I want to put the validation into a separate method. Right, so this here, next states, encodes the validation rules for part 1. So we're going to filter that exactly. And we're just missing a close paren. In fact, I think I'd rather write this in this style here. In the state. Yeah. Area of the grid. There we go. Oh no, did something change? Heat loss new position. So we are now getting a higher answer than we did formerly. Okay, let's look at this. Let's take our start state again, and we're gonna do some quick debugging. And maybe after maybe in this case I'll leave my tests out so we can test as we go. S. That's our start. And let's do s dot straight. So heat increased by 4. And let's do like another straight. Heat increased by another 1. And let's just verify that. So day 17.text. Oh, it should increase by 3 first and then increase by 1. And here it increased by 4 and then increased by 1. So that tells me our heat loss isn't quite right. So total heat loss should start at 0. Heat loss at a new position. You should always be doing the new position. Um, if air contains P, then grid P, right? So grid s dot pause, and we're just going to move east. So the first one should be 4. If you move east twice, it should be 1. Um, oh, I see. This is happening on the example. Let's switch again to the example. Yeah, 4 and then 1. Okay, that's fine. That's fine. And let's say we turn right. So s dot turn right. So that's going south. We should add 3. And let's say after turning right, we go straight. Hi, Zara. So I'm doing a bit of a review and refactor here. Um, the big difference here is that I've realized that this here, this triple, will sufficiently prune your search state, right? And it is exactly like my state without the heat loss. So just the position, direction, and streak is all you need. So this doesn't prune aggressively as what I wrote, but it prunes enough to be performant, and it is simpler. So like this is what I'll put up in an article. We gather 3, we gather another 3. Great. And I refactored my state a little bit so that we can just move through states separately. And then our next states here will filter all the validations. The validation is separate from the new state generation, right? That way, my next states too can be completely written in terms of these 3 functions and encode its own set of validations. But I'm finding I have a little bit of a bug where the answer has just gotten higher than it was before. And that happened right after I changed these from optional. It might be my streak limit. Oh yes, when my streak is here, it has to be less than or equal to 3. There we go. Okay, that changes back to 102. And these here look right. We'll just leave those down below as tests. And now we can work on part 2. So for part 2, our next states changes up a bit. So we still have this filter that the inbounds filter, s.streak. It's not going to be straight. It's going to be turn left dot straight straight dot straight dot straight. So we can either move straight, or we can turn left and move straight a few times. That's straight, that's straight, that's straight, that's straight. Or we can turn right and then move straight 4 times. And then, yeah, then we put a filter on that and make sure streak is less than or equal to 10. And then now search to the only thing that would change. In fact, let's just change it right here just to test it. The only thing that would change is that next states adds that little 2. 112. And is that the correct answer for part 2? 94. So the same thing might not quite work for that. Let's see what states it's going through. Um, the pruning is intentionally simpler here than what I wrote previously. And I'm hoping that just this trajectory is, oh, wait. For part two, that's not the only thing that changes. My start states also change. Hmm. Because we can move right, or we can start we can start by moving south. Uh, in fact, let's see what we get for next states from S using this function. So S dot next states 2, and let's do it for each print line. Okay, so we have 1, 0 looking east. Oh, you know what? These states are valid. Uh, hold on. No, that's not valid. So that is, we've just moved forward once. Hmm. What we could do here is add that if we're moving straight, um, let's say straight till 4. Def straight, straight in 4. Because then, well, I don't know, let's see how this plays out. So next state's 2, we have S dot straight. Let's see what the next state's 2 from this point is. That next state's 2 for each print line. Oh, hold on, let me change some code above. That's compilation. This right here, we're not going to find that just yet. Okay, so again, there is a turn right, and there is a movement forward. So we are still moving forward one by one. Right, and those are valid states. I guess we are just missing the shortcut. That's all. So it's fine to have that. That will still work. And in fact, this dot straight, dot straight, dot straight, dot straight. This isn't. Oh, wait. This does it too many times because turning left does actually move you once forward as well. I've done that shortcut. So this would actually work just fine. We don't actually need to do this. That's just a shortcut that reduces our number of states that we visit. But from each of those states that we visit, there's only one path forward anyway. So it's probably fine. At least it's not exploding, right? Uh, and so now we get the answer 82. That's a lot closer. That tells me, oh, no, we should be getting 94. So that tells me we've screwed up horribly. Again, these filters on next states 2 less than or equal to 10. So we're still not getting into any invalid states, right? We're only we're not getting into any invalid states. And I'm fairly confident about that because, oh, no. Now we're not encoding that we have to move at least 4 forward. Right. So this is just this problem. That's all that's changed. So turn left can only happen Yeah. So straight dot straight dot straight. Let's try this again. And then now we'll have two original states, right? So we'll define a search to, but I do want to like collapse these into like one function I can pass parameters to. So we'll leave this as just a normal next states. Make sure we get the right answer here. And then we have our first two states. We could do a special case for the origin point. Let's do this. So let's go to next states 2. And we will take these 2 bits out. And this is what we will do if the streak is greater than 4. Sort of the same thing we did last time, but with this filter changed. So if streak is less than or equal to 4, yes, this is what we should have written at first. Or rather, if streak is less than 4, then our only option is straight. I think that's a nice way to encode it. Otherwise, we do this. Okay, yes. That is much nicer right there. Now, search to, the only thing that needs to change here is that we use next states to. So val ends 2, and search to. And I think what I'd like to do is pass in as a function. We do have other compilation errors here, I suppose. We're missing a parent. Oh, what did we do there? There we go. 94. So that is a correct answer. Okay. So let's pass in as a function. The start and end are pretty self-explanatory. So we'll just have next states as a function. So search next, and this is going to be a function from a state to a list of state. Okay, and start, this is going to be point.origin, and end can just be area.bot right. Now, search 1 is just underscore next states, and search 2 is next states 2. Or no, not search 2. There we go. Interesting. Oh, right, because here we don't use next states, so we use that next states function for visiting. Or rather just next. There we go. Okay. So this is how this cleans up. There is only the only way we do any deduping is the set of the trajectories, which are the position, direction, and streak. Right. Other than that, this is a very standard Dijkstra search. And then now our state has these methods that we can call independently to transition to other states. So forward, left, right. And we have two different next states calculations, right? One just does straight left or right turns as long as we're in bounds and the streak is less than 3. One first checks if the streak is less than 4, then we go forward. We can only go forward. Otherwise, we can go again straight, left, or right, and we do the similar checks here. So I think this reads very nicely. This is what I'll use when I write up an article. And this as well commit as my clean code, as my cleaned up code for Avena code. So, what's this? Okay, day 17. And then this is 2023, day 17, cleaned up. We'll push that. And I do want to have people review that. So if you excuse me, I'm just going to drop that in the Scala Discord. So the Scala Center writes up articles every day, and they have it on the website. I can show it here. Oh, nope, that's a leaderboard, not the, I don't know the website link. Oh, hold on. I do know it. I'm just in the wrong. Here it is. Right, and then people from the Scala community take turns writing solutions. Today is my turn to write a solution, so we're gonna fill this out. But, you can see solutions for past days. This was the mirror bouncing. Oh, this is quite long. Anyway, I'm gonna share my code. So day 17, let's do GitHub Advent. This, I think we want to go back to just main. No, is that, no, it has to be like tree master. Okay, we're gonna do this. Go to my repo, click on 17. There we go. The only thing that changed here is to remove the library code that I'm using. Yeah, I'm happy with this. Oh, let's go back to the calendar. Hey, Blue, good morning. Yes, 7 more days. I missed your message a second ago. We are into the hard problems now. Seems like a lot of people gave up or took a long time last night. I took 4 hours and I still in the 3,000 rank range. Which honestly, I was expecting to click that and see like over 5,000. It felt like it should have been easier. Maybe while I'm working, day 17, then you can sleep longer again. Well, what happens to me in past years is like Christmas Day comes, and I'm like, what do I do? What do I do now? It's midnight. You get addicted to it. And then I spend like the next 5 days just going back over past problems and tinkering with them and like, oh, let's just refactor. Let's make this more performant. Let's make it concise, whatever. Okay, so we're not going to use any imports. Do we dare just delete that first? No, let's do stuff like this. So grid p.y and then p.x. We'll put that on another line. And there's no area, but we do need like an X range and Y range to check inbounds. So def inbounds p point. In fact, we'll just make that a method on our point class. So case class point x int y int. Def inbounds, and this can be let's see, y range. We have a y range and an x range, so we're going to do grid dot indices contains y, and then grid y dot indices contains x. Sure, yeah, that works. So now we no longer need the area because we have an inbounds method. So we're using like area dot contains. If p dot inbounds, and now we can move in a direction. So def move. Yeah. Let's see. North becomes y -1. Okay. This looks good. Now we can pause that move in a direction. And then we need to define our own direction. So enum dir case. What order we do this in? North, south, east, west, sure. A def turn right. And def turn left. I'll complete the whole thing. There we go. Okay, now we can remove this import. We don't need this area anymore. And then area that contains, we can replace inbounds. s.pos inbounds. s.pos inbounds. Okay. That adds about 30 lines of code. But it's very simple boilerplate code. And no longer dependent on my library. I wonder if these next states should not be methods. These will be a balanced family. Yeah. Finished in 1 hour. Yeah, it's like the closer it gets to all the family times, and the faster you need to go, and the harder the problems get. Okay, so I'm going to save this as day 18. We have less than a minute left. Val input get lines at 2 vector, sure. worksheet is function, just making sure. Okay, we are ready. We are ready. Finish in 1 hour. I'll be right there with you. I'll try to finish in 1 hour myself. Thousands of people every day do that. All right, good luck. Yeah, 3D stuff, hopefully. Oh, okay, we have more direction stuff, and there are some like hashes along with them. So left, up, right, down, and some thing. Large backlog of part requests. In fact, we also need a large supply of lava for a while. Okay. They've asked you to look at the dig plan. Okay. The digger starts in a 1 meter cube. Oh, hole in the ground. Specified number of meters up, down, left, or right. They're in full 1 meter cubes as they go. They say cubes, but this is not 3D. Each trench is also listed with the color that the edge of the trench should be painted. Okay. When viewed from above, the above example would result in the following loop of trench. Okay, right 6, down 5. Really? That's down 5? Left 2, down. Okay, sure. We've got that. We've got that. So this is a grid again. Area equals area of that grid. And what are we going for? Oh, wait. This is not a grid quite yet. These are instructions. So val input. This can be a list. And we interpret that input. So this is like a fold left problem. Val start equals point origin. And we have like a step function, def step. Hold on, let's make sure we know what's gonna happen here. At this point, you got the interior says 1 meter deep as well. Now the lagoon can contain a much more respectable 62 cubic meters of lava while the interiors dig out. Okay. If they follow their dig plan, how many cubic meters of lava could it hold? Okay, so we just want the area inside, including whatever. So what we could do, how large is this? First, let's get the boundary. And then this might be like another even odd rule thing. So we're getting the boundary by connecting a bunch of points. We could reuse ranges, little areas. No, I don't think we want lines. So we'll get all the points. Point, set point, we return a set point. And we have instruction. And I think we want to put the points first. Okay, so instruction match. And that's not what they're going to look like. It can be more like case R. Yeah, R, and then we have some N, and then color. Oh, I think we want a map. The colors will matter here too, eventually. So we have parens, and then we have a hex. We'll call it raw hex because it's not quite a color itself. And then maybe we'll make like a case class for color. So this is going to be direction, there, and okay. And RDLU. I think I'm going to do, oh, I hate this autocomplete. We want to translate right, left, EU. We already have a north, south, east, west that we can parse. So we'll just take advantage of that. .zip with this is gonna be like a 2 cardinal, def2 cardinal, and we have a direction string, sure. And we're returning a dir. You know what? We're just gonna straight up do RLDU. So this is U D R L. Okay, unfortunate that I didn't already have that. So we're gonna have like points plus what is this? We have to have a current location. So we have a current location. We have a set of points that we're adding to. And then we have a color for all of these. So I think we want a map point to color. For now, color will be a string, but we might make that case class. Right, and we'll just pass in the raw hex, but we might actually end up parsing that into something. Just look at how this would be used. So we have input dot fold left, and we have a start state, which is an empty map dot empty from point to color, and that's all that's in there. We also have some hidden state, which is like our current position. So we have point dot origin. There we go. Pause points. I don't think I want to call this points. We're going to rename that symbol to plan. Yeah, we'll call it the plan. And then the instruction. And honestly, we just pass that to step. Step, pause, plan, and instruction. So this is position, which is just a point. Plan, which is a map from point to color. We're going to do plan. We're going to do this for multiple points. So pause. We're going to do like a line. So line from the current position. Which ones get that color? Maybe I double check that later. It starts in a 1 meter cube hole in the ground. Edge of the trench should be painted. Okay. So we're gonna do pause dot move direction. to pause dot move from direction end to int. And we get those points. Um, and then we fold left the plan, just updating that plan updated with p and raw hex. Okay, that's exactly what I want. And then now this whole thing, I don't know where that came from. We don't need that. We just pass on pause and plan and instruction. Well, we'll just call this the plan. And then we want to like look at the size of that area. What's this direction? Oh, let's just call this raw direction. Valdir equals 2 cardinal raw dir. Um, required what? We found a map from point to color. Oh, we want our final location as well. Yeah, we could return that as part of this. So we have new position, val new position equals pause move that many times. And we'll use that here. And we'll return a tuple. So new position that. Right. I'm just going to remove the type annotation for now, let it infer that. And now what's the issue here? This required a map from point to, oh, hold on. Well, updated plan equals that. And then we'll do new pause to the updated plan. There we go. Now that works. So plan dot keys iterator. Let's do that. Or, we can just do area of that. Area dot bounding for a map. So for that plan. Map from a point to a T. Oh, this is the final position and the plan. We'll just do that. Okay. So this is our bounding area. Val area. And I want to check the size of that. Area.size. Oh, okay, that's big. So our answer is less than that. We want the area inside. Can we flood fill? Let's draw this. Wait. We can area.width 379 area.height. Take a look at this. We're gonna draw this print line area.draw. Like it or else we don't want that. If plan dot contains p, then this. Oh, it's just a dot. Okay, that should draw it. So we're going to copy that worksheet output. We're going to full screen this, go to our Scratch, and take a look at this. Okay, for now, we're going to do a flood fill. Like that will, what's going on here? Yeah. For now, we can do a flood fill, but there's probably a more efficient way because these are fairly large. The flood. I know. Let's do it this way. Iterator dot unfold, and let's start the origin, and we're just gonna subtract those points. So yes, exactly. Point dot origin. Well, an empty set too. Set dot empty of point, and then a set of point dot origin. And we're just like gonna get the size of this. So this is val flood. Not quite what I want. I'm just gonna copy paste old flood code. Uh, xargs grep flood. Let's grep for 2023. Whoop. Day 10. Okay, day 10. Flood. Yeah, we're gonna copy this code. Visit current. Um, yeah, we're mostly gonna do that. All we want is the size of that. We're gonna reduce it with the union. We don't need this bit here. And then we'll do flood dot reduce with union and dot size. And val outer size equals that. And val ends 1 equals area dot size. Oh. Minus outer size. Diff boundary points. I don't think we need to diff any oh yes, we do need to diff boundary points. Val boundary points equals plan dot keys dot to set. Or plan just plan dot key set. There we go. Okay, so our answer is 157701. 157701. Okay. Not quite right. Let's see. Let's look at what outer. Let's draw outer. Do like outer dot size down here. So if outer contains that point, then let's draw like an X. Lots of plan contains P. Let me draw that. Otherwise, we just draw. Go to our scratch. And zoom out a little bit. Wait, there are no X's. Oh, okay. Okay, so we started filling out the origin. That wasn't all the points. So this goes all the way to the top. Why don't we just pick a top, a point we know is inside? Yeah, let's just pick an arbitrary point on the inside, draw it out. Val inside point equals point. I don't know, what is the area size? So 0 to 378. So let's say 150. 150 by 0. Point. 150 and 0. And we're going to say inside point. And then this is now inner. Nine, 4, 3, 9, 2. Let's just take a, we'll do that. I'm pretty confident. Oh, no, that's not quite right. Area dot size minus inner dot size minus boundary points dot size. 89912. 89912. Oh, now I have to wait 1 minute. Okay. Well, let's print this and see what it looks like. So go back to our scratch. So that was indeed an inner point. Our flood fill does catch it all. Yeah, so area dot size minus inner dot size. Wait, are we supposed to count only the inner? Let me just check this on the example. So day 18.text 2023. We're going to save this as example. And we'll try this on the example. Of course, the inside point is going to have to change. What's an inside point? 1, 1. 1, 1. Okay, this is what ends up drawing. And for ends 1, we get 8. Okay. Let's take a closer look at this. So area dot size. Yeah, let's look at inner dot size. 24 points on the inside. And then boundary points dot size. Are there 38 points in there? Are we missing 1 point here? Well, hold on. Like my answer I get is 8. Oh, what I've calculated, I removed the inner area. Ugh. Okay, so it's inner dot size. The answer is inner dot size plus boundary points dot size. There we go. So this is 62. Great. Great. 70026. There it is. 70026. I had inverted them. Okay. Oh, yes. Apparently, I got lucky and 1, 1 was on the inside. Okay. Uh, bu- 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 Now let's look at part 2. And let's see how I did. 1,000. Oh, it's almost top 1,000. Oh, okay. Let's keep going. We'll be top 1,000 for this part. The L's are right to be concerned. It'd be too small. After a few minutes, someone realized what happened. Someone swapped the color and instruction parameters when producing the dig plan. They don't have time to fix the bug. Want them to ask if you can extract the correct instructions from the hexadecimal code. Okay, the first 5 digits encode the distance in meters as a 5-digit hexadecimal number. The last decimal digit encodes the direction to dig. 0, 1, 2, 3. Okay. This is very easy. I'm just gonna change my code here directly. Oh, the distance is gonna be much larger, isn't it? That's gonna be significantly larger. So this is many, many cubic meters of lava. We need to go back to using areas, right? We can't do a flood fill here. We have to do a union of areas. Um, 952 billion. We also need to use longs. Okay. So before we move anywhere, I'm going to save my part one. So we'll just do like a quick commit. So add day 18. Um, 2023 day 18 part one as solved on stream. Oh, I'm not getting notifications for your messages. Paint and flood fill? Yeah, paint and flood fill. How many of you in chat are also finished part one? Yeah, we're gonna have to do unions of areas. Let me just draw this and see. I think what I'll first do before interpreting this is try and make this work on this grid. Let me take a look at this grid. Scratch. Oh, don't you hate it when your share just turns automatically without you? Okay. Like, let's say we had a set of boundary points, right? Then for each row, we could do a computation like this, right? Like we can sort them. We can sort the boundary points first by like y value, or like filter them by the y value. That might work. And then we just even odd count this, right? Like every pair that's a range, we get the range of that size. And it should always be even, right? It should always be even. So we can like group two coordinates at a time. Okay, that's what we're gonna do. Two coordinates at a time, turn it into an interval, get the size of that interval. I've got this. I've got this. Day 18 on worksheet. So we're not gonna flood. Still want the area. We're gonna compute like some sort of ends one. So this should be 70026. That's what we're going for. Just leave that as a note. And wait, all this stuff I deleted. Might actually want to. We'll just comment that out. So we know we're going for 70026. Just commenting that out because I want uncommented so I could draw again. We don't even need an inside point anymore. Just put that as part of that comment. We do need the area. So the bounding. Okay. And area dot y range. So we're gonna do like a for y and area dot y range. I think we might want to group these boundary points by y values and then actually sort them. Makes sense to like filter repeatedly. I think we just do a group once. Boundary points dot group by dot y, and then let's do like the x values. Um, it's a group map. Group map group by dot y, map all these values to dot x. Um, and then we don't really want it to be a set of int, but we can fix that. And then val slice area. So given a set of x, right? So nums equals a set int, and we're gonna turn it int. So this is a def. So nums dot sorted dot group, right? There's a group grouped by 2, and these can have just nothing happen. Nil is 0, and we're just gonna do a to b dot size rather than doing any kind of math there. And you know what? This can be a long. So val areas equals that, and we'll just do like areas dot sum. Areas dot map too long dot sum. Dot to list dot sorted, sure. Okay, and then with this group map for each of those, we're just gonna map values. Map values slice area dot values dot sum and 1 equals that. An implementation is missing, so we had one where it was an odd number of boundary points. Interesting. Okay. If nums dot size mod 2 equals 1, then we want to print that. Or you know what, we'll just search for that. Where was our slice area? Where did we use a slice area? Yeah, so we're gonna group these by y. Group y and values dot find dot size mod 1 mod 2 equals 1, and then for each print line. Okay, this might be like the very first point. So I think when we're looking for boundary points, Uh, where's the start? Boundary points contains point of origin. That's where we started, right? Mhm. Um, what is the plan for point of origin? Okay, like there's a thing there. Okay, I'm not completely clear on this. There's a single row. Let's get a y value for that row. Um, just find. We're gonna do like a collect first. Collect first case y x's if x is dot size mod 2 equals 0, then y. So 69. Nice. Um, okay, when y is equal to 69, let's just go to Scratch and look at, oh, I don't know where y69 is. Is there some point that has an odd number of boundary points? Oh, hold on, hold on. If we're going across a big group of points, let's go back to our Scratch. Right, like here along the top. Right, like this could very well be odd. Um, so I know where the bug is. I don't know quite how to fix it yet. So we've done this grouped by 2. I think we do a scan left and make ranges. If we only look for vertices, we can't look for just vertices. I mean, if we had just lines, we could look for just lines that are vertical that hit this point, right? But we haven't gone that approach, so we're just gonna have to be clever here. Okay, so a slice area. Um, we could just take like a sliding set of 2, and then when there's a gap, we stop computing. And then in that case, like this would be a scan left. Let's try again. And we will start with 0. It's not just gonna be b minus a. Thing is, this thing also contains some sort of state. If I did this as a unfold, then the next point is too far from the previous point, then we switch, right? and we start summing again. Let's do that. So iterator.unfold, and then we'll start with like nums.tolist.sorted. We'll just like pop stuff up from the top of that list as we progress. And what else is there? There's like our sum, and then there's like our current sum, or like our total sum, current sum. What are we unfolding? At some point, I guess we're returning points that are inside. We can just return ones. And then like we return a 0 when we move from. No, there's a state, so we can start with like a false. And in a range, so numbers previous in range. I like the start of that. And we can match on nums. If it's nil, then we are done. Nothing matters. Otherwise, we have an n and we have the rest. If n equals previous plus 1, this is correct, right? If we're adjacent. Then we continue. We return n because we wouldn't return n though. Right, like we return just 1. 1 is all we're adding. And it depends on if it's true or false if we are in a range. So if n, oh, hold on, this previous, that's not quite looking for. Oh, you know what? Hold on. Let's backtrack a little bit. Let's just look for adjacent groups. So let's just do val num sorted. Just call it sorted. List.sorted. You got zip. Sort of zip.tail. I'm not gonna do that though. And yeah, as long as these are adjacent, we'll keep outputting them. Well, groups of adjacent, I don't know. Oh, you know, we can keep consuming. So we can do a span. Output a thing, and this is an unfold. So iterator.unfold, and this will be ranges. And list.empty of range. And then we don't want that. We want like a case. Ranges is our state, and we are also, oh wait, we need these val pairs. So we still have like pairs to consume. What we're returning ranges, so pairs is our state. Okay. Yeah. Pairs is our state. And we'll do like pairs that span b equals a plus 1. And I don't know that I want to do this with a match. We're going to call this like range and the rest, right? And we can do like this none stuff here. We handle out here. So we continue. Oh, whoops, what's this? So we have like an option, not when, pairs at non-empty. Then we do the span. And we have like a now range rest. And we don't need a match. And what is the type of range? This is a list of int. So we're going to do range dot head 1. This is the left side. 2 range dot last 2. And then we continue the state. Okay. I think this needs to be in a paren here. Okay. So this is an iterator of inclusive ranges. And then ranges, dot map, not too long, dot map, dot size, not too long, dot sum. Okay, that's much better. That took me too long. Too long to do. Now, slice area should be correct. Let's uncomment this. Head of an empty list somewhere. Okay, then the option, instead of the option not when, here's that non-empty. We only do this one until it's non-empty. So there should be something here. Oh, hold on. We still have to do something. I guess something can go to itself. Yeah, so these are in fact all of the ranges of whatever points, but we still need to do like the odd and even between these ranges. So we need to group these by 2. In fact, the stuff I'd uncommented sort of had what we wanted. This kind of thing going on here, right? So we have 2 ranges. Yeah, we're not going to give these nice names. We're just going to do ranges.grouped. We're going to ignore all these cases. So a.min to b.max.size. It's not a member of any. Oh, wait, ranges. Let's turn ranges into a list. We can do that. Okay, now when you uncomment this, let's see if we get the right answer. We're still getting ahead of an empty list somewhere. At Scala option.when. Inline 3. Where are we looking at the head of an N? Oh, here. So this range. How could that possibly? Oh, right. If it's empty, then there is has a gap. Um, let's see, in that case, we just take the first of rest. So range dot head option. I know I should have written head option. And if there is a head, um, or we'll do this, if range dot non-empty, then we do this, else we do thing is, this is a span, right? I can take all of the, I guess that there could still be consecutive groups in there, right? So all we're doing here is getting consecutive groups. If there is not a consecutive group, then that thing is by itself. Yeah. So this A is not just one less than B. So we return A to A. And as for the rest, yeah, B is something, I think we just take rest dot tail. Else rest dot head dot one to the same thing, rest dot head dot one. And then we just do rest dot tail, and we just do the same thing over and over again. Implementation is missing here when we have just one thing. So these should be groups that are even. We're still having this kind of thing go on. Oh yeah, that's fine. So ranges dot size. There should be an odd number. There can be any number of ranges, right? Oh, oh yeah. We don't even need to do this grouped anymore. Now this range can represent something like, let's just draw it out. So it can be like dot dot dot. This is the first range. That's a second range, right? It needs to be an even number eventually. Stick and dip. Thank you for the follow. But this is the kind of thing we want to parse into like 4 ranges, right? Or, like rather even 4 ints. So we can make this like a true false part of our state. Are we inside or outside? We wouldn't call it ranges. We would call it boundaries. And then we'd group by 2. Cliffs or edges. This is an edge detector. Okay. JP Vix, thank you for the follow. Okay, so we're looking for edges here. So we take the pairs of all of these in order. Oh, I think there's some I can end. Like the first edge is always just gonna be the very first bit, right? If you find we if we find a span of these that are all the same, then we really just care about the very first bit of that. And what we're not using then is the last B. So we get this. I'm not gonna call this range. I'm gonna say I mean I guess this is a range, consecutive. We'll call this consecutive. And if consecutive.nonempty, consecutive.head one is the thing that we return. So this is gonna return a bunch of ints. And then we change our state pairs and we'll say, are we inside? So we're gonna start with false. Yeah, right. So finding our first thing turns that to true. Okay, false. I'm gonna turn that to true. To rest and true. And now this is the case. We have the pairs, then we have the is inside, right? And that starts false. Oh, and this is the case if we are inside. So if is inside, then we do this. Right? Take the very we don't want ranges though. We just want this bit here. The rest or if not is inside. And let's put that in the else branch. So if is inside, then something else. So if we're outside, it becomes true. Um, and what happens if the consecutive is empty? Then we still do rest.tail. We're gonna turn this to true. So we're gonna turn that to true. And what's it gonna be? Rest.head.one. And in this first case, we still use just rest. Yeah, I think we still use just the rest. Well, hold on, that consecutive block ends at some point. So the next thing we should return is the last bit of that. Okay, so maybe we should return like actual ranges here. In which case, if we're returning two at a time, then we don't actually need all of this state, the state with it is inside or outside. We don't need to keep track of that. Okay, let's just think it. I'm going to scrap this for a second and just go back to salvaging this bit here. And this is just an off by one somewhere. But the range is not empty. We do this range. That makes sense. Otherwise, this is and this thing is our first edge, right? This is our boundary. It can be a very wide boundary, but we're still gonna take like the minimum of that and the maximum of the next one to get our full size that's inside. Yeah, yeah. And then what happens in the very in the very last case? let's look at something like this. So we take our first bit and we take this, right? Um, Now let's say our next bit is also something like this. So this first case is going to be this case here where it's non-empty. We take that to that. And then in this case here, yeah, that's the first range we return. And then this is kind of our rest, right? And then we look at this, we're going to say range is non-empty. And what we can see is this is our A and B. And we're gonna say our range is empty, so head.1 to rest.head.1, so just to itself. And we're gonna drop that off. So now it's just this pair here. Right, and then at the end of this, we're going to have to give the very last value. Um, so we have all the tail points. We just need sorted.last. Okay, like we take that. This is going to be our very last tuple, right? When we get here, we're going to have we're gonna go into like the empty case. We're gonna head.1 and head.1 and rest.tail. If it's nil, if it's so let's think about these two cases here. Maybe we have one that's like this, right? And we still need to be able to get the very last range. So in the first case here, we just return last. So ranges plus sorted.last, sorted.last, right? And we can handle that in this question mark case. And in case it's a bunch of the last bits here, then we have what we end up returning here. We take while it's consecutive. We're gonna get all of these and it's gonna be included. Yeah, it is going to be included by nature. So we're gonna do like a.min to sorted.last. Oh, we got two in there. I delete that. Dot size too long. Wait, what is areas? This is. Oh wait, you want the size of this? Not size. We don't need a dot size down here. Here we go. 54930. I don't believe that's the answer I got. This is more efficient. Mhm. I'm going to make a quick assertion here. Um, assert if area dot size mod 2 equals 0. Make sure this is doing what I think it's doing. Then areas dot last. We're gonna make this a lazy list. Lazy list. Then areas dot last. Size. No. The size of this be greater than 1. Else I think that's the only assertion really. If it's even, then the last one was a range. We're gonna rephrase that as this kind of thing. That's a non-member of iterator. Wait, areas? Why is this areas? Oh, this is ranges. Else true, sure. Okay, that assertion, does it fail? Okay, so we still have some cases then. Oh my god, why am I struggling so much with this edge detection here? We're gonna rename this to edges, just so our intent's a bit more clear. It's a list of ranges. Do another assertion here. If it's ever odd, if it's ever odd, let's print. In fact, let's not do an assertion at all. We can just comment this out if we need again. If edges at size mod 2 is odd, then we're just gonna do a little quick print line. So sorted. Let's look at those cases. Okay. So 98 to 109, 124 to 127, 144 to 213, 234 to 41. Wait, 1, 2, 3. That's even. Did I miss edge dot size? Mod 2 equals 1. Oh, right, yes. That's because of the last one, right? The last one doesn't get included. What I could do, I could pad this at the end. Just the last piece twice. We can also print line edges. Okay, and this is the case our thing handles, right? Because we have 98 to 98, 109. Okay, right, we have a bunch of single ranges. So we get those grouped two at a time. Two, wait, 1, 2, 3, 4, 5, 6. And this last one, we just pair that with last to last. right? That's exactly what we do right here. So let's try this. Uh, let's try slice area with a case that looks like this. So dot dot two big groups. And we'll do a set of 2, 3, 4, and then 8, 9, 10. Great. Wait, the slice area for that is perfect. 1, 2, 3, 4, 5, 6. What's the slice area for 2 until 10? That's also perfect. Okay, so which one gives it trouble? Let's keep looking at this. Say we have 2, 3, 4, and then 10. This should be the same answer as above, 9. Oh, no, no, no. Interesting. Let's see what gets printed there. So slice area should print stuff. No, it doesn't print any. Interesting. The edge size is not odd. Let's just do 2 and then 8, 9, 10. That should also be 9. And that there is correct. So this here is wrong. That should be 9. But I'm not seeing any like failures here. Right? Like what causes the failure? Wait, is there a failure? No, there's no failure. We're just getting the wrong answer. Oh, okay. Right, right. Yes, because we did this thing. But apparently that's not always correct. So in this case, 2, 3, 4, and then 10. So let's print those ranges, or let's print those edges. Print line, edges. And for this one, oh, we'll just to list that. So we have 2 to 4. Oh, and then we have 4 to 4. Interesting. We shouldn't have 4 to 4. I think we need to do like a dot tail somewhere. And then we have 8 to 10. I think we need to do rest.tail here. Tail of an empty list. Okay, not quite. So this does get the correct answer, but it does end up having like 3 ranges. So I think this is accidentally the correct answer. So we look 4 to 44. And then we have the range 8 to 10. And then we do like the last, so it's like 8 to 10 is matched with 10 to 10. Okay, so after we take that 2 to 4, up here where my cursor is, so we have 2, 3, and 3, 4 are out. And now what's left is 4, 8. Yeah, 4, 8, 8, 9, 9, 10. So let's see, if rest up non-empty, then rest up tail, else nil. Oh, let's write that in the parens. Okay, now we get 9 because we had the range 2 to 4 and 8 to 10. as the answer we should be getting, because everything in between should count too. We're getting 9 for all of those. 65278, was that our answer for part 1? 70026. Okay, not quite, so we need to look for more edge cases here. Let's do this. 2, 4, and then 8 and 10. So that should be 3 plus 3. That should be 6. Okay. Um, 2, 4, 8, 10. Oh man, I'm spending too long like just testing this for correctness. I'm not even sure if it'll perform on the full set, which I haven't, I'm not even able to generate quite yet. Oh, I'm gonna take a quick break to look at the stats for today. How many people have finished? So I would still be in the top 2,000 if I finished like right now. And that's going up pretty quickly. Okay. I'm still happy about this 1006. Maybe you need to look for failing cases. Um, or we need to make sure we're computing the correct thing. Like this seems totally fine. Let's see what it's printing here. So those are the edges. 2, 2, 4, 4, 8 to 8. Oh, we are missing 10 to 10. Oh, yes, but then we fill that in, so that's fine. 2 to 4, and then we fill in 10 to 10. That is also fine. 2 to 2, and then 8 to 10. Yeah. So in each of these cases, we fill out 10 to 10, right? And when it's the case that 10 does come as part of the range, that seems fine so far. What if we try something bigger, right? Like this is one where that 10 to 10 gets filled out. Let's do 12 and 14 and 18 and 20. That gets doubled to 12. That's fine, that's expected. This, if I make that 19, that should be 11, right? So that's fine. Our algorithm seems to be working as expected. Maybe the bug is somewhere in here. So group map. Let's see, when we're summing these up, are we below? We're below. This is a set. We're summing on a set, aren't we? Group map y dot x the x values, and then that view dot map values its slice area. And values dot sum. Let's take out some of our print lines. We might want to put something else in that's more useful. Values is like an iterable. Why don't we generate all the inner points? And let's print what we're getting. Well, inner points. We'll call it call it inner. Is the set of points. And let's do this. Group map. We're not going to group map, we're just going to group by. Group by. And this isn't just inner, this is the inner as well as the boundaries. So let's call it something different. Let's call this the Doug points. We're going to group by .y. Map values by slice area. Dot sum. No, we're not going to do that. Oh, hold on. This is actually kind of hard to do because this just gets you the area. You'd have to do like a modification of this. That's not gonna work as a test. What we could do is return these ranges. Yeah, let's do that. We'll do a separate function. So def slice area, and we'll call this like slice even odd. Slice even odd, or slice inside ranges. Slice Doug ranges. List of range inclusive ranges specifically. Do edges. No, we'll do areas. This function nums set of int, which is going to be slice Doug ranges. And we're not going to do a sum. We're going to do dot map dot size dot sum. That shouldn't change anything else. This 0 is going to be 0 until 0. Just an empty range. In fact, that should never happen. Right, because we have even and odd here. I'm just going to triple question mark that. It does not like something here. Something needs to be turned into a list. Let's I don't know, let's just do list after right here. And we take off the sizes. Okay. So these things should still work. Slice area should be a long. We required a point. Was this originally like a set of points? Oh, right. Yeah, this. We're not actually using that. Okay, we're getting that same thing. Okay. So now we're taking these rows. We're not taking the slice area. We're going to take the slice Doug ranges. And for each of those range, map, that's an X value. And we're going to do a point with whatever Y is in there. So we're going to turn this map values into a map. So we have Y. And then I suppose we have X's. So we get the slice ranges of those x's, and we map each of those x to a point x, y, and that's going to be a flat map. And what we have at this point here is what's the value of x's, and a set of point x's dot map. You know what, we're going to do a group map dot x. Herbanoid, hi there. Welcome, welcome. How's your night? We do an advent of code. Wait, this is group map. Here we go. So I'm debugging something. Is this Ubuntu? No, no, this is WSL. So this is Windows on Linux. Advent of Code, it's a series of small programming puzzles that comes out in December. So every night at midnight, new problem comes out. Oh yeah, so like this is Ubuntu, but this is inside of Windows. But like, you know, like all my terminals are gonna be Ubuntu stuff. And my VS Code is running on the Ubuntu side of things. So yeah, I'm doing admin code. I'm doing day 18. You have to put Calu in a VirtualBox machine. Yeah, I know that can be a pain. But this problem here. So there's the issue here? X is a range. Oh yeah. So we have a bunch of ranges. I guess we're gonna take these ranges and we're gonna do another flat map inside. I'm just writing something really ugly right now because I just want to get like a little test in. X to point xy. Okay, not quite. Oh, Herbanoid, thank you for follow. It looks like we just reached 256 followers. Yes, I'm both a software dev and a programmer. Um, all right. We have the problem we have right here. Oh, I've been working professionally for like a decade, but I started programming as a teenager. And the problem we have right here, I can show you what we're working on, is we're calculating an area, the area of a shape like this, except it's gonna be a much larger shape. So we have to do, we can't just do like a flood fill like you normally might. Like flood fill works for part one of the problem. Part two is gonna have a much larger area. So what I'm doing is I'm working on ranges instead. I'm gonna take like the size of that range, and I've gone through and I'm going line by line, and I'm converting a line into a series of ranges of areas I want to compute, right? And right now, it seems there's a little bug in there. So I'm going to convert my ranges back into points and then draw them on the map, much like this one, so I can see what area it thinks I'm getting. And for that, I'm just writing this ugly bit of code here. What's going on? Found a point acquired at nothing. I don't believe that. Okay. So we might have to write this in a more, in a nicer way. So we do this group map. I'll just leave this old bit commented out. And at this point, we have a map from a y value to a set of ints, to a set of x values. And let's turn that back into a list. And let's do a map over that. I think I'm going to want a flat map, but let's start with a map. Case y and x's. Now we get the slice dug ranges. Slice dug ranges is, let's take a look at that. The the inner ranges, the ranges that'll be filled in. So we flat map each of those ranges, turn into a point. I think we want flat map out here too then. Because, well, let's just see what it returns here. In this case, let's list a point. Yeah, we want a flat map. Now we just have a list of points, and we're going to turn this whole thing into a set. So set.from, and I'll just give it a type hint that we're going for a point. Oh, temporary Alex, thank you for the raid. Oh, time enjoyed. You're here. Good to see you. Good to see you. For Alex, were you doing advent of code? I'm gonna assume you were, just given the time of year. Oh, Fizzbuzz, I recognize your name from somewhere. Where have I seen that? I've seen you around. I think I've seen you on advent of code leaderboards. Which, by the way, here's my leaderboard if you want to join. Um, yep, Fizzbuzz from the leaderboard. You got quite a bit of help today. So for part 1, I was ranked number 1006. For part 2, I had the idea, and I think the idea will work, but there seems to be I'm currently debugging. So I've done kind of like an even out. I've gone like line by line and counted boundaries. Tried to do like some edge detection to find some boundaries, and say like the first set of boundaries is my inside bit, and then etc. We just do it grouped by twos, right? And when I did that, I wasn't getting the same answer as I was getting for part 1. So just now, what I've just done is convert this into a set of points like I had in part 1, instead of just ranges. And I'm gonna draw out what this is doing as a way of debugging. So we'll do that. Do you think FP reduces performance? I think FP and performance is very situational. There are cases where it increases performance because FP makes certain things easier to handle, in particular concurrency, right? FP can help a lot with concurrency. If you think of like a Hadoop MapReduce, that's sort of using kind of FP ideas. And you're able to parallelize because you don't worry about shared state, right? And even on a smaller scale, you can get better performance out of like, memoizing, laziness, etc. So I think it's very situational. In a lot of cases, like you might end up having, you might end up using a lot more memory, right? Because you don't edit things. You make copies of things. Okay, so we're going to draw this. Print line, area draw. If points contains P, then we're going to do X. We can start with the plan, actually, because the dug points actually also includes my plan points. Okay, I'll copy that worksheet output, and we're going to put this in Scratch too. Zoom out quite a bit. Interesting. Okay, so we have some where our even odd is kind of inverted in the wrong order, right? What this is supposed to look like is this. Oh, it also seems to be flipped. Let me see. No, I mean, that's the same general shape. Okay, so what are these edge cases? Let's try to go to the same area in both. Mhm. Okay, so without even comparing the two, we can kind of see some of these. Just weird looking patches, right? I'm gonna focus down on here. Now this bit here should look like a little peninsula. Oh, I need to disable line wrap. Word wrap, toggle word wrap. Here we go. Let's look at toggle word wrap for this file too. Okay, so this here should be a peninsula. We determined that this is inside. We should be determining that all of this is inside. Oh, I see what happens. Yeah, I'm not realizing that this doesn't continue in the direction. Okay, so if both things are ranges are longer than one, well, this could still end up going up. Okay, I think I should do something a bit more traditional. Um, hmm. Thing is, I don't want to go for like every point. I mean, I guess I could get this point here and ask if it's inside or outside. And then that'll tell me this whole thing should be. Hmm. Man, I spent so long writing this code up and it's still not correct. Uh, Maybe I should stop and pause and think for a second about if you want to even use this approach, right? Like this approach has been get every y, and for every y, we get the x values of points that are dug out. And I'd assumed that we can use just that alone to determine whether we're inside or outside. Um, Suppose we did these in terms of lines. Oh, had we done these in terms of lines instead of just, so my boundary here is a set of points. Oh, and for part two, it shouldn't even be a set of points because some of these boundaries can be super long, right? Let's take a look at the problem statement. Um, yeah, some of these boundaries, so even the boundaries need to turn into lines or ranges. And having those as lines would have made what I just wrote easier to write. And I thought about that. I'd said, oh, you know what? I should convert these into lines rather than a set of points. So I don't have to do this edge detection, like check if 2 points are adjacent. And I chose not to do it because it was already written this way, but I needed to change it anyway. How's my solution so far? Works for part one. Part one, I did it based on sets in flood fill, right? Like I did a set of points for the boundary, and then I just picked a point on the inside and I did flood fill. And I finished number 1006. For part two, I'm not quite there yet. I can show you the code here in a minute. I'm just thinking over this. You know what? We'll let this simmer in the back of the head for a second, and we're gonna work on the other part of part two, right? Turning these boundaries into lines. This thing will become easier because it'll work on a set of lines instead. Oh, and you know what? Mm, I will know if we are inside or outside. I might know if we're inside or outside based on the arrangement of lines, right? When I'm crossing, here, I've got it. So look at this. Over here, I'm crossing a thing, right? I have a space where it's in the same direction, it's horizontal. And what I do to determine whether this is inside as we have been or outside as we have been is look to the right and say, okay, are both of these right things in the same direction? They can be like, okay, this is actually included. If they're in opposite directions, then we do this algorithm that we're doing so far. But what if it comes from the top? If it comes from the top, oh, I mean, if it comes from the top and this is still opposite direction, then it is still just doing what we're doing. If they both come from the top, then we include this next space too. So I've got my rules, and I can do it because of lines, because I'll have lines that go vertical as well as the lines that are horizontal. So we can handle that. You got a big hint for a library algo that got you to the solution. Okay. I do have like a library of my own. So what was the other day? There's another day recently where we had to use ranges instead of just flood fill. Flood fill was not going to work. You remember that? Um, okay, I've got this. I should have stopped to think about this. I don't know, an hour ago, and then I'd be done by now because I'd be doing the solution I'm about to do right now. Yeah, was it day 10? Isn't No, I don't think it was quite necessary here. I was able to do some of the flood fill. No, not with the maze. I think it was like day 7, 2023. Nope, that is a poker one. Day 5. Yeah. With the seeds, there were some very big intervals, right? Like, look at this. Like 3, 4, 340 million to 500 whatever million. You don't want that to be a collection of points, so you just do a range. anyway, anyway, this we can do. I'm gonna scratch any part one stuff altogether. So let's start with the new rules here. The first five of the raw hex um, is a distance. So let's get the distance out of that. Val distance equals raw hex dot take 5, and then integer dot, I think there's something in here. Integer dot from dot parse int, and I think you can give it your string, and you can say it's base 16, right? Just try that real quick in a terminal. Nope, nope. You want integer parse int, and let's take f f f f f. Okay, that's correct. And then direction. So we're gonna do raw hex 6. We're gonna match on that. It's gonna be something like this. Not quite. Um, let's kill the rest of that. So 0 has meaning. We have right, down, left, up. So in terms of my cardinal directions, that is east, south, west, north, right? Dir dot east, dir dot south. I guess we could, no, the ordinals are going to be different. Dir dot west and dir dot north. Um, and while that parsing code will be useful later, I'm not going to use it right now because I want to have the smaller area that for, I want the smaller shape whose area I know. So we will still change this to plan being, I guess it's a set of lines. Maybe it's a sequence of lines. We'd rather have it in order. There's not even really a color anymore, right? Yeah. We don't even really, we never cared about the color. Let's take out this. We still do need this cardinal thing. It would have been more fun for the colors to matter. Yeah, I think so too. But like, I don't know. What do these other numbers mean? If everything is in the hex direction, right? That means nothing now. Now the first part doesn't matter. Um, anyway, we're just gonna return a new line. So line from, and we're not gonna take the points. So we're just gonna do like that plus new line. That plus this line, yeah. In fact, we just do this here. Oh, and line should actually start at our current position. So there is no new pause. Okay. Oh wait, there's still a new pause somewhere. Okay, there we go. works. So now we have a set of lines. We can still get the boundary points. Yeah, I'm gonna still do that for now. That'll be useful. So, uh, we do have a plan. So the plan, it's gonna be even simpler. Um, we don't have, oh, we have an origin point and set.empty of line. And I think we can just do, I guess we have to keep code that way. There we go. Direction. Oh, the direction code I removed. Let's rewind a little bit. Where was the old direction code? We like, oh, you know what? I'm gonna, how do we redo? Okay, control Y. Oh, no, 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 no. Ah, crap. Crap. Okay. South. Let's rewrite this. West. And then I should have just written the code instead of trying to undo that far. Um, yeah. So this stuff is commented out. This is a set of line. Yeah. And I guess this could have been. I'm still gonna write this as a fold left for right now, as that particular fold left. And direction. Val direction equals 2 cardinal raw direction. Like that's the line I need to write instead of doing undos. This problem is such BS. I mean, I like it. I like it. And I think I have a solution for it. I just should have gone faster. Plan plus line. I took like an hour detour on my optimization. How'd you do today, Chris? Um, color string doesn't even matter anymore. Okay, that works. Line here. We don't need this. This is now just a set.empty of line. Code doesn't change. This does change though. Oh, right. We do still ignore the endpoint. There we go. So plan. Double definition. Where is plan defined elsewhere? Plan. Oh, yeah, right here. Okay, so plan dot lat map points. And then this is just do set. So we still have the boundary points. Other things should continue working. This no longer works. Paired up bounding of plan. Um, okay. We still want. In fact, the plan is a bunch of here. We're just gonna take all of the start and end. We actually do want to calculate the area efficiently. for our bounding box. So plan dot flat map, and we're gonna do so a line L dot P, do like a little list here. L dot P and L dot Q. And then we want the bounding area of that. How many bounding definitions do I have? I think one should work on a set of points. Okay, we'll make this a set. Set. This is a flat map. Okay, and now we should still have an area defined. Right. Like this is all of the corner points. In fact, we'll just give it its separate name. Well, corner points. We found a point and we required a line somewhere. Oh yeah, we're not gonna use this for now. Okay, everything should still work. But now we can do things in terms. This slice dug ranges, we're gonna ignore that altogether. I think what I want is for a given y. So I can assemble my lines. There are two approaches we could take here. So I'm gonna go back to my map. There are two approaches we could take here, and that is we could turn this into a bunch of areas. We could take the union of all of these areas. This is going to be potentially a lot of areas, though. I mean, it's going to be a lot of lines. We could turn lines into areas by like looking for our corner points and splitting lines into two, sort of. I'm not sure I like that. Another approach is to take a given y value and find every line that crosses that and every line that goes in line with that. Yeah, and there are a few cases we can have. If we have, we can have two, we can have a vertical, a horizontal, and a vertical line together in 4 different configurations. And we can have just a vertical line, right? These cases here that are easy. So just a vertical line that crosses over. Okay. And I guess we take all of our lines, which could be many. Let's just beat how many lines we have. I'm gonna comment this out. It's not even correct. Dare I just delete it? No, I don't dare just delete it. All this stuff. Comment that. Comment that. And that's not even gonna work. Okay. Long list of old stuff that doesn't work anymore. So plan.size. How many lines are there? There are 700 lines. Let's update this. I guess in the old case we have distance equals n.to int. So we're going to change this line to distance. And then we're going to comment out these 2 old implementations and bring in the new. How many lines do we get? Oh, it does not like something. String index out of range. 6, and this is for raw hex. Didn't raw hex always have? Oh, hold on. That should be 5. Okay. So now we've parsed out all of the lines. Wait, why is it taking so long to do that? How? I mean, how many instructions are there? It's still gonna be the same number of lines, actually. It's gonna be like 700 lines. Um, so it's actually gonna be like the same either way, the same performance, because it's the same number of lines. It's just one case has shorter lines. Uh, Interesting that changing that. And is this necessarily be a parsing? What's the maximum value? Oh, I think we just did it. So the maximum value is like 1 million. That's still gonna be a parsing. We need like more than 16 hexes. Is that right? I don't know the exact value. It is still evaluating an older worksheet. I'm going to cancel that. Okay, here, now we're getting errors. Recursive value plan needs type. Is it a recursive value? It's not really, like this should be shadowing it. This is a set of line not found. Set does not take parameters. Something weird is going on. I'm just gonna reboot. It seems like I killed my worksheets. Okay. Not crazy, right? Like this is working a second ago, rigging the size of the plans. I could just start writing code. Let's do that. Okay, so for every y value, we don't even need to do this for every y value, do we? I guess we could do this for every leftmost border. For every y value is going to be too large. Let's think about that again. I mean, that's another reason my other approach wouldn't necessarily have worked, right? There might be like huge swaths of vertical area blocks like this, but much larger vertically. Hmm. There are only 700 lines. Um, let's say we take all the vertical lines and horizontal lines separately. And then what if we sort vertical lines? Toggle grab here. By distance to the left. And it's hard to know if it's going to be the leftmost given range unless we also have. Oh, you know what? What if this is kind of like a pigeonhole kind of thing? Right? Like we take the leftmost and we take an area. So we take basically this whole area and we add that. And then later on, when we get another thing, like this line here, we're gonna be like, okay, is this line contained in an area we already have? Then this becomes a negative area, and we subtract that area. And in this case, do we even need the horizontal lines? I think we can do it just with vertical lines. So subtract that. This is kind of like day 22 of 2021. Subtract that, add that area to the end. Does that work? Let's look at something gnarlier, right? So we take this area. For each line, we have to look at potentially 700 lines in the past and see if any of them overlap with this line, which that we can do easily. But what if multiple overlap with this line, right? We count how many overlap with this line. So here we have a line that takes an area. Now here we have a line. It overlaps with one line that we've already processed. So this becomes a negative area. And then we get to another line that overlaps with two. So that becomes positive area, negative area, positive area. Okay, so I think I have an algorithm. I think this will work. And I'm curious if anyone did the same approach. So let's go back here. Okay, so val vert equals plan dot filter is vertical. I think it's just vertical. Yeah. And actually, let's do whichever one is smaller. So we're going to count vertical and horizontal. Count horizontal. Oh, I mean, of course they're identical. Okay, so this is n squared. This is 400 squared. So we have the vertical lines. And then we turn this into a set of two areas, right? We process this whole thing. So this is like a big old fold left. We're gonna sort these. Sort by yeah, x value. Plan dot to list. I don't know why this needs to be a set. Like this can be a list from the start. But whatever, we refactor that later. Okay, and we're gonna do avert.fold left, and we're gonna get two sets of areas. Oh, hold up. I want to see what some of these numbers are going to be. Some of these numbers might be huge, and we might need to have our lines handle longs. So let's switch over. I don't know why this caused an issue last time. Okay, new direction and distance. Let's see what our area becomes. Well, that's running. I don't know why that's running for so. I'm gonna leave that up and I'm gonna go use the bathroom. Be right back. Okay. Okay, we're back and I'm looking at some of these values and wait, it says the worksheet is still, how long did it take to run that? Output of metals. Why did it take a minute? Parse that. This is very simple. For one, this doesn't need to be a set of lines. Let's change that. This is a list of lines. Down here is going to be a list of lines. Corner points. We just add the corner points here. That would be the right type. Oh, we have broken the thing again. Let's just metals, restart the build server, or restart the whole server altogether. Let's see if that makes it work. And I need to do a little bit of math here and think about if a lot of my library code for areas still handles just ints. So let me think. If that's maximum value for like a horizontal value, they're like 300. Oh, yeah, like we can only have, if we go like max value all the time, we can go, there'll be 300 that are horizontal. So like 300, like 400 are horizontal. So 200 along the top and then 200 going back the other way. Of course, it's going to be looping back. But if this was the biggest square possible, then it's just that value times 200, right? So we can handle this. These are all going to be ints. The areas are going to be longs, but but we just have just have ints. So we have to be careful about calling area.size. And what's going on here? It's evaluated day 18. It has some issues. Plan. Okay, yeah, we just const it onto, you just const that line onto the list of plans. That works. Is it a line or a point? Right, shouldn't be point.origin. No, that's fine. List of empty line. We found a point next to a tuple of line and point. That's a return type of step. Yeah, this returns a point. Oh, right here. Nope, I don't need to work right now. It is 2 a.m. here. And I live in the East Coast. I work West Coast hours. Please finish before Christmas. Yeah. I mean, it's a good thing that the last problem is always one part and sort of easier than what comes before it. I think Eric gives everyone a break because it does come out on Christmas Eve. And a lot of people are visiting family for that or some thing. Okay, this, we're just gonna tell it what it should return. This should return a point. The whole thing honestly should just be, this whole thing should just be inline here. Right, the code is simple enough. But you know, that's fine. Let's leave it that way for now. There's a new position. Oh, there's a new line, right? The line from pause to new pause. There we go. There we go. And area up bounding corner points. Corner point should be a set of points. Okay, this is going to be a two set call right here. In fact, you can do this just on the vertical points. So yeah, this is a thing that can be useful for now. So I'm going to leave that in there. And this can be vert.toSet.flat map. Vert is not double defined. Okay, and then we have our area. And I'm gonna have to debug whatever's going on here. That's weird, right? I don't know why uncommenting this. This is just simple parsing, right? That shouldn't. Oh, this should also be north here. That shouldn't change any performance, right? Maybe we'll do it in a separate part step, see what the numbers are, and maybe that'll give us a clue as to why that's causing some sort of issue. But for now, let's check if we can get the same answer we got before with our new approach of, it's not pigeonhole principle, is it? Where you like take a Venn diagram and you do like subtractions, add and subtract as we go in and out. Okay, so we have our vertical lines sorted, and let's just write it out. So let's do a fold left, and our accumulator is going to be two sets of areas. Set.empty area, and the set.empty area. And this is not visit current inline. This is um, we have adding, subtracting, and line. And we have to convert this line to an area and decide. Or, call this like added. These are things that have been added and subtracted. And for each of those, we count how many overlap. So added.count contains, so like we take the area, a.contains line.p or a.contains line.q. Well, hold on. Yeah, basically that works. We're not doing anything with this. So we can do the same thing for subtracted. So we'll just call that A and S. And then if A plus S mod 2 equals 0, well, we have a new area either way. So let's define that val new area. And we can define that above here. What will the x range of this? The y range will just be this line. So area line.p.x to the full area. I think I should rename this full area. Or the bounding area. We'll call it that. Bounding area. Bounding area dot right. And this one here, this will depend on the direction of the line. And I don't like normalize my lines. So we'll do like a dy, val dy, and dy will never be 0. So line.q.y to line minus line.p. So we can just do by dy.sign. There we go. That should work. And we can test that with an arbitrary line. Let's just comment this out real quick here, and we'll get a quick test. Val line equals line from 0.00 to 0.010, right? If we change the order of that, we should still get the same area. We'll define dy here. And yeah, that works. And if we reverse these, we have a 10 here and a 0 here. I think you should do like the area.size and make sure it's the same in both cases. 169. 169. Great. We have a new area. And then we have the count. then what we return is uh, we are going to be adding this. So added plus new area and then subtracted. Otherwise, we do added and then subtracted plus new area. And those still need to be areas because we need to check future points against them. So now added, subtracted is the result of this whole thing. Yeah. So added dot map dot size dot too long dot sum minus same thing. So val ends 1 equals that 48696, and we get, interestingly, we get negative. Let's take a look at these added sets or added areas. Um, okay. I think we are subtracting a portion. I know what we're subtracting. So like we add all of that to start, right? And then this, we are subtracting too much because we're subtracting the boundary as well. That still doesn't explain exactly why it's negative. But certainly it should start at the x afterwards. Let's go back there. So the new area depends on whether it's being added or subtracted. If we're adding it, then we keep that. Otherwise, new area is p.x plus 1. Or rather, we could say p dot east dot x bounding area dot right. And it's the same y line. It's just shifted right a little bit. Okay, that's a little bit better. This here tells me, oh, we can't take this size. I'm gonna change my library code. Yeah, we can't take area dot size because we're multiplying two large numbers, which might end up negative. So point dot Scala area size. We're gonna convert. So eventually we'll make our area work on not just ranges, but any numeric type, or not just int ranges, right? And that'll be a refactor for another time. Def size width times height. We're gonna do some sort of integral type, and then n dot apply. Does it have an apply method? But that's wrong. How do we construct an n given an int? I guess we could do like from int. Or there we go. There it is. Integral n, not from int. Oh, I was forgetting to do integral n, not just n. Okay, that works. Let's go back to day 18. And now this size, we're going to say long. We want a long size. And the widths and heights should still be fine because they'll fit in an int. We confirm that up here. Um, Method size does not take type parameters. Yeah, that's because you haven't recompiled. I literally just added it. Okay, point.scala, def size. This is size in area, right? Method size in class area. We're gonna do like a metals recompile. Oh wait, this is not compiling yet. Hmm. Oh, we need to import the fixed integral ops. We're just gonna say dot times right now. Dot times. Okay, we're gonna import those ops. Oh, it knew the import. There we go. Okay, so that should compile. That should work. We're still getting negative areas. Let's just do the sum of all the added things. That should be positive. That should overcount. And that is a larger thing. I'm missing. Horizontal lines do not matter. That I'm pretty sure about. Let's just check for all greater than 0. Okay. Same thing here. For all greater than 0. So there's no overflow going on. Well, let's look at some of these areas. Or let's look at the example. Let's go back to the example. That way we can really look at these one by one. Okay, and the answer we're looking for the example is 62, not 26. So let's do this. Added for each print line. Okay, let's compare that. I'm gonna split screen here with the okay. I kind of want to sort these by their left side. Let's do that. Added dot sort by left. Oh, added dot view list, sort by left. Oh, you know what we're doing? We are mapping and summing on a set. Oh, that is dangerous. Let's see if this changes. That has gotten me. This is the second time it's got me this year. And that got me huge last year. We'll just do iterator. Subtracted dot iterator. Okay, and we are getting a different answer. So that was indeed a bug. There is another bug here, though. So we had the range 2, 6. Oh, if they only overlap, there are two here. So the 0 to 6, that's the x range of something. 2 to 0. Okay, the 2 to 0 and the 7 to 5. Yeah, that makes sense. This one here shouldn't be negative. This one should be positive. but also it kind of overlaps. A portion of it will be negative. So we should subtract this area. Okay, so it could be the case. Well, that will depend on whether. Hmm, yeah, so like this bit onward to the right, this could be negative, but it's not going to include. And now there could be multiple cases. So this is all our first positive bit, right? This should be here, our next negative bit. And then we have to be able to determine so if they are connected by a horizontal line, it could make a difference, right? If there's a line from here to here, then we should not include that. Okay, so there are a few ways in which these two could overlap. If they overlap, if they share a point. This could start as a negative, right? And then this could add back. No, because this isn't now like sharing with a future point. So what we're gonna end up doing is saying like, okay, this area here is negative. Which I think would be fine. Let's look at another. And then now when we take this area and we decide it's going to be positive, and we see that's connected to a previous line, then we have to add in that area as well. Are there other weird edge cases we're missing? Let's say this here went higher. Well, all that matters is what it's connected to. The piece that's connected to. Let's look at this. This is kind of gnarly, right? So we're gonna have a positive, then we're gonna have another positive here, and it's gonna be connected to this one. Oh no, I think this one will be considered negative by our current algorithm. This should be considered largely positive because, and for the most part, it isn't really overlapping. It's only overlapping at that one point. So if you do find something that not only overlaps at this one point here, let's say we had drawn up and then back down, then there's something that overlaps at just at one point, but that doesn't matter because that should be handled at that point, right? There should be a big negative space here, and then this is positive. So if it's connected to the previous one, then this will be positive, but we need to take their overlap and make that negative. We need to just subtract their overlap. Yeah, and then that overlap can be subtracted all the way to the end. Okay, so we have that positive being added. And this here happens. This can just be negative all the way to the end. It overlaps with multiple, and it's not connected to any. So I suppose we should have a map of connections. And we can construct that. We do like check all of the lines, and we do check them like in order. So we know what's connected to what. So this will be a big negative. And this here, it'll be a positive. We'll find that it's connected to that. So we're adding all of this. This here, from this way on, was a big negative. So we need to add back a little bit. Well, I mean, it's a big negative for like all of this, right? That whole thing. So again, we just take that top border, that top border, and we remove those points. Wait, no, hold on. This bit is positive. Yeah, we had previously negated all of this. So yeah, this bit over that negative area that intersects with this one. That intersects at the top, that shares the same top. Um, we take that whole top and we add the whole top from here on back in. No, the whole, everything back in. Yep, yep. Okay, we've got it. We've got it. Okay. So we do have a new area. And then we have like an overlapped area. And I guess we could do, does it matter if it is like an added or an, so this is even, this is the adding case. I'll just annotate that. And this is the subtracting case. Okay, so when we're in the adding case, we just have to look at the cases that are subtracting. Subtracting dot filter. So we have an area. Oh, and then top equals p, the top of our line. Oh no, we have our new area defined. We can just say it's the same top. Okay, so there is an area. We'll just call it. We'll call it A. We'll just call it an S. We're gonna shadow. S dot top equals this dot top equals new area dot top, or oh, could it matter? Let me think about that real quick. Whether it's top or bottom that is connected. Let's look for some cases there. So in this case, like they share a top. What if they only like shared a bottom? Right, like this went back up. That'd be a case like this one, which could be dealing with like this negative space. Not quite. Are they ever going to share a? Let's say this is the bottom of some. Let me think about that. So we have here is a top. What if this had gone up and was a subtracting case? Oh, that's a subtracting case. Yeah, so that's not going to happen. Right? If this is a subtracting case going that way, then this here would also be sort of a subtracting case, now wouldn't it? Oh, our counts are also still wrong. Sort of. No, I think we're fine on our counts. Oh, but we do need to shrink our area vertically. Oh no, we've been over this. We're just gonna go the whole thing, and then we can fix it when we get here. Okay. So the rule then is if our area at the top is also the top of a subtracting case, or s dot, we handle the bottoms differently. Let's just start with the top for now. And now we need to add things that need to be subtracted. Hmm. So given an area, another subtracting. Oh, this is a little bit of a headache. So we're adding an area is connected to a previous thing that is subtracting the whole just top border, the top lines. The top line needs to be subtracted. So it is going to be the same X range and then just top to top area. And it's going to be S dot X range and then S dot top to S dot top. Okay, and this can be all wrapped into one collect. Collect case S if S dot top, well, this case right here, equals new area dot top, and then return is this. So these are S's. We have a name for this. This is like overlaps. And then subtracted gets updated as well. Dot include all. I'm just gonna union overlaps that to set. Okay. And then you do something similar here. Val overlaps equals adding that collect. As we're going to rename this symbol to an A. Oh. You know, we're just going to make it generically O for both of these cases. O. Oh, and they have to be connected by a line. Yeah, like this might work for the example, but there might be too many coincidences otherwise. Okay, we changed this to O. difference is this is from subtracting from subtracted. Yeah. So we add back the overlaps. Union overlaps dot to set. There we go. X range, that needs to be capitalized. Camel cased. Okay, great. We're almost there. Now let's take a look at what's going on here. Mm, Okay, so what's going to happen? We're going to have oh, this area here, and this area here, and we're going to get to this one, and this one should be added, but we're going to find it. We're going to find it, and we're going to say, oh, there are all these overlaps. So if it overlaps with another adding, or if it's connected to another adding, rather, we could we could have a set of horizontal, and we can just look for that line, see if that line exists. If that line exists, we make it smaller. Make this whole thing smaller. Oh, those are all adding lines. Let's go back to the whole thing. Nope, 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 nope. The whole map here. So we'd start considering these points because this is what has showed up. Right, this is negative. This overlaps with a positive piece, like this is being added. But actually, nothing should happen in this case. Oh, interestingly, they are connected. Nothing should happen because both these lines go up. This doesn't go down. Right, we had discussed this. And I hope this is not down a path I don't actually want. Hmm. Yeah, let's look for connections. And I think all that matters is connections, not the overlaps. If it's connected to like a positive that's going in the same direction. So let's say that like they share a bot border, right? Oh wait. We have already considered this, right? So like if the bot border of the subtract is a bot border at the top, then we don't think anything of it, right? But if the bot border is the top border, like here, okay. The bot border of this is a top border of this. Um, and that's another add. Okay. So in that case, we just make the area smaller. Okay. We can we can do this. We can do this. So we're adding a bit. This will be the new area if um, no, we're going to comment this out because first we're going to look any adding things overlap it. Is it possible that a subtracting thing also overlaps it? Um, let's look at that. So like here's a case where a subtracting thing overlaps it. What if it overlaps it by like less? Well, we still have to worry only about this portion here, right? Which needs to be added back in. So it could also, let me see if I can find one, right? Like this could also go out here. Let's look for like something that goes sort of inside and to the right and stops. Like here, right? Like this is adding, oh, nope, nope, nope. We want, like a hook shape. Uh, you have a hook shape anywhere? Surely there is one. Zoom out. Okay, here's a oh, you got it. Great, great. What's your leaderboard name, by the way? Okay, so this is sort of the shape I was looking for. Maybe not quite in the right direction though. But let's consider it from the other direction, right? Let's say this is a bit that's negative. This is a bit that's being added. So it shares opposite borders with the added bit, which means we'll only add these 3 rows. And it does share a negative with this, so it shares a top border, a same border with this, so we do need to add this negative bit in. Okay, so we can do both things. And what I might be able to do, I still kind of want to use this whole 4 thing area. So what I might do is just subtract the thing that gets counted twice. And that'll mean like more errors in general, but it'll be easier to compute. Yeah, so those are some compensations. Okay. Um, and we name this like AC and SC, added count and subtracted count, just so things are a little bit less confusing. And now we're going to take all of the added dot collect. Well, first we need whatever our top is. Oh, and our top is fine. We're just going to use this new area. Now we don't need to do this line.p.y. And just do new area.top. Area dot. It can be the bot or the top, right? And we have to make sure they are actually connected. So as long as it's opposite, the o.top equals new area.bot, or it's it's Marcus. You're on rank 15 right now on your board, but you saw some stuff late evening. Okay, still haven't finished yesterday's. Fair enough. Yesterday's had some trickiness to it. Or o.bot equals new area.top. And then whichever one is overlapping. Actually, we'll make these two separate cases. Case O, if, right? And in either of these cases, you'll only take areas that I guess the bot left is connected. Hold on. We're going to add a set of edges of horizontal. So vert is a list. Horizontal we'll just know that this is a set. So plan is plan a set, plan.toSet. Then we get filter, horizontal, sort by. We're not going to sort at all. But we are going to normalize. Map case line PQ if p dot x is greater than q dot x, then we'll just do line QP. Otherwise, we just return a line. P dot x is greater than, okay. Yeah, the lesser one ends up to the left. Okay, so we add another condition here to both of these. That's going to be and line, new area. And it's going to be different for both of these. So or we don't need to name it there. So case O. So O dot top left and new area dot bottom left. There's a line connecting these two. And it doesn't end up being as clean as I want it to be. But this is, I do believe this is going to work. O dot bottom left, new area dot top left. And, you know, there's probably a way I can clean this up. So what are these? These are the areas that we have to subtract because we've added them twice. So we're gonna do like area, new area dot x range, and then o dot top to o dot top. Sure, that works. Let me do a similar thing here. Um, and this is going to be the added twice, val added twice. Or, like the add overlaps. Okay, right. And now what's a better name for these overlaps of the subtracting bits? So subtracting bits subtract too much. My profile, thank you for the follow. We don't need this line anymore. This isn't the overlaps. It's not just overlaps. Subtracted. So you're subtracting an area. So here we're trying to add an area. Previous subtracting area has a line that's connected. So now there's too much that has been subtracted. Need to add back, I guess. Add back. We'll call it that. And then case O if O dot bot. Okay, we do the same thing but with bots. And then now we also need to check that they're connected. And the horizontal line exists. Line from for the top us could be O dot top left to area dot top left. And for the bottom, at top is just going to be turned to bot. Oh boy. Okay. So added union add back, stuff that needs to be add back. Dot to set. And then subtracted union. Oh wait, hold on. Subtracted union added twice. Yeah. You get the stuff that's been added twice. Okay. And if we're subtracting, rules change a little bit. I wonder if there's probably some nice symmetry here, right? So we still do like that val new area. And stuff that's subtracted twice needs to be added back. I'll subtract it twice. I'll subtract it.collect, and if it matches, I think if it matches, then we need to add back that top line. So top, it's just gonna be top all the way across. It does have some nice symmetry. Like I could probably like generalize this a little bit more later on. Bot. And then val subtract back. Yeah, we'll just call it subtract back. Let's see if it knows a pattern by now. Yes, top and bot. Wait, new area to bot left. Okay. That I'm almost happy with. So added, you have to union with like stuff that's subtracted twice. To add that back, subtracted, union, subtract. Subtract back is a weird name, but oh boy. We have a head on an empty range. Head on an empty range, this happens somewhere. What we call like a top left function, probably, something like that. Yeah. Area dot left. So we have like an empty area. So some area that we've added. We need to filter those out. But at least it compiles. It compiles, it just doesn't work, not yet. Uh, okay, when might like top left not work? Right, all of these areas should have. That should only fail. What are the areas I'm constructing? It's probably one of the areas I'm constructing, right? This wasn't failing before. So O.x range, these areas should all have X ranges. I'm gonna assert that every area we have. Yeah, let's do some assertions. Assert, and what are we gonna do? Added dot for all. X range dot size is greater than 1. Right? And do that for subtracted as well. Okay, do we get an insertion error? We don't get an insertion error. Y range dot size should also be greater than 1. Right? That's pretty straightforward. But I don't know why that would ever be the case. Let's see what it fails on. Assertion failed. Okay. Assert. It also takes a message. Let's do this message. Oh, you know what? We should flip this around a bit. So we're gonna do like added for all A, and then we do our assertions. Assert that Y range. Well, assert A dot Y range dot size is greater than 1. And then we're just gonna print that area. A. And then we just do the same thing for the subtracted one. Oh, wait, it's the for each. There we go. Area range 2 to 6 and range 2 to 2. Oh, no, greater than 0. Greater than 0 is what we want to check for. Because there will be a lot of skinny areas, right? The little overlaps that we're adding back. Hit on an empty range. What is that empty range? Oh, unsafe code. Matensis, thank you for the follow. Okay, let's see if we can get this by 4 a.m. Um, um, it is failing on like a top left or something, right? Left, top left. Let's look at top left calls. Top left. Oh, that top left. Why would an area never have a top left? Let's look at the definition of top left. We make a point from left and top, so it calls for left, which takes our x range dot min. Why would we ever have an area added here? Let's check this, the area of all of these added and subtracted bits. Um, oh, right. No, let's check the area. Oh, this is how we define the areas. All these areas come from here. Man, when I first wrote this, I thought like this was going to be a little simple fold left. Okay. O dot top to O dot top. Maybe this here, line P dot X to bounding area dot right. That's always going to be fine, right? Especially since it's a 2, like if P dot X all the way there. And line P dot Y to, let's do an assertion here. Assert, and let's also check the X range. I think the X ranges are always fine. Check that Y range. Do we get an assertion error? Nope. So that's a place we create a new area. Oh, you know what? I'm going to do something very copy pasteable. I'm going to do import util that's chaining ops dot star. That lets me take a value like 13 dot tap. No. Util dot chaining dot syntax. I think it's just dot star. Okay. Now I can tap each of these with an assert. It's going to look like this. Dot tap. So we have an area and assert a dot range at size is greater than 0. And we'll print out that a. So we're just going to add that assertion everywhere we create a new area and figure out where this bug is coming from. Lex Farwin, thank you for the follow. Farwin. And welcome to the stream. Okay, we've added all those tabs. Our code is getting so hard to read. Interesting. So every new area I create, apparently, the Y range of those areas is large enough. Add that and that in. It might be happening right down here. Nope. There are no assertion. There are no assertion errors. Call this def right now. Um. Oh no. I guess that does have to be a val. I just don't want the red lines everywhere. Okay, every new area I define gets checked that it isn't that it does have some sort of y range, right? Because this failed when we did some sort of like top left on some sort of area that's been added. We start with two empty sets of area, and yeah, all of these subtract back. We perform that assertion, and all the subtract twice. We perform that assertion. Uh, I still like my approach enough to keep doing it, and I feel like as soon as this bit here is debugged, that should just give me the answer. So I'm so close. I don't want to give up on this. Um, okay, so we're still getting. It's not being cut by an assertion. Oh, is it happening even sooner? I done an empty range. Happening because of left and top left. And there's like apply or else stuff going on. I'm not sure where that's coming from. We're doing a collect. Yeah, that's coming from the match statements. Just want to see exactly which area is struggling with that. Why don't we just go through all of our areas that we have? So we have added and we have subtracted. And let's put an assertion here that uses the top left. And we can put that in like a try catch. What was the error we're getting? We're getting like a no such element exception. Okay. So added each A. We're gonna try A dot top left. Oh, it's gonna fail before we get here. No, because yeah, this is the first time we are using these. We are constructing them. I feel we're constructing them. Try that. Case that util that nope, no such element exception. Print line A and then throw E. Sure, let's do that. Wait, am I doing this wrong? Not want to. Okay, let's just wrap this in a Scala util try. Fill that try A dot top left. And then I guess we assert that it's true. Assert T dot is success. Otherwise we print T. There we go. Okay, we're still getting the same error, so maybe it's one of the subtracted ones, right? Good. But like the try should catch that. This is still coming from a top left call, right? And we are trying top left. First thing we're doing is trying top left on every area we have. Good success. That assertion just passes, huh? That assertion passes, and yet one of those fails here later on. Are we doing like transformations on the area? Would that be it? Um, let's see. We have a new area. It'd be like a new area, that top left call. Well, we do check. Let me assert that the new area has a top left. Right, instead of doing like Y range dot size. Um, yeah, so instead of this, we do assert try new area dot top left. Otherwise, we print that the dot is success. Otherwise, we print that new area. And we got to change all our assertions down here to something similar. Example, it's going to be dot tab a goes to that thing. And we assert a. Okay, we're directly trying top left. Apparently it's not because of Y range dot size, but I don't know why it wouldn't be. Right, top left relies on left. Oh, it relies on X range dot min. Yeah, left is the part that's failing. Interesting. So yeah, it was never going to fail in Y range dot size. I'll just add those tabs in. The tab afterwards shouldn't be an issue. Apparently it's not failing. Any tabs. Let's tap this too. Why not? Okay, every time we construct an area, we tap it and make sure it has a top left. We're going to import util.try. Import util.try. There we go. So that compiles. Now we should get an assertion area. Empty range 7 to 6, 7 to 9. My X range. Okay, my X range can go from right to left. I see. I see. Line.p to x to line. I don't know why I did this. So I did the right thing here for the y. I don't know why I didn't do it for the x. So silly. I mean, I should just have my lines normalized upon construction. Like the leftmost should go. Whatever. Line. Oh wait, I guess it's x. Dot x. So by dx dot sign, just gonna add this in a bunch of times. And we should be able to remove all these tabs. But that's only happening in the new area bits. Okay. That should fall on something else. Step cannot be 0. Oh, yeah, that could indeed be the case. Um, yeah, if a line is on the very right side. Oh, in fact, it's almost always going to be 0, right? Um, oh, you know what? That's why this is fine, because bounding the area dot right is always going to be 2. Yeah, bounding area dot right. This is the rightmost point possible. Like, this should be fixable by doing like bounding area dot right plus 1. And we don't care about the x dot sign. It's always going to be 1 plus 1. Okay, hey, that works. That doesn't quite work. And now I've written code that's hard to debug. Okay, so we don't need the dx. But we can take a look. Take a look at these. Once it's being added, the only thing being added, yeah, this is debuggable. Let's take a look. So these first two here are these two blocks here and here. They're three down, and then we're adding this range. But when we add this, we should also add like a subtract range. Good day to you too. Is it morning for you in your time zone? Okay. Oh. 4 a.m. here is gonna be my limit. I have half an hour. I can do this. So we have all this adding. What? We should have subtracting. We should have like a lot of subtracting actually. Yeah, those will be the 4 adding cases. Okay, so that looks fine. Wait, let's look how far each of those are going. 0 to 7. So 0, 1, 2, 3, 4, 5, 6. Yeah, they go extra. Right, that's fine. Oh, I think we need to add a big subtraction at the end, maybe. The rightmost. Oh, no. The subtractions are handled by other bits. So let's take subtracted. Okay, so the range 2 to 7. So all the way across, and 5 to 5. 7, 5 to 5. It's a little line. It goes all the way across. This is a vertical line. That's not right. You shouldn't have vertical lines. Oh no, that's not vertical lines. Sorry, 5 to 5. It's just at row 5. 2 to 7 at row 5. 0, 1, 2, 3, 4, 5. Yeah, so since we added this block and then we added this block here, we should subtract stuff that gets added twice. And it shouldn't go all the way across. It should go from the bottom left of the new area to the end. not from the top left of the old area. Okay, so stuff that needs to be looking at what's been added twice. Added twice is up here. Great, so we have our condition. And if o dot top is new area dot bot, then we do new x range. O dot top to O dot top, that's fine. Yeah, we take the x range as the new area. So that is fine. So stuff that gets added to the subtracting set, that's added twice there. Subtracted, union, subtract back. So something needs to be subtracted again. Let's take a look at this. We're taking the old thing, dot x range, and that might not actually be the case. So let's say, oh, where's the case? I don't think a case like that even appears here, right? I should print like the areas that get added at each point. So this is a subtraction. This happens while we're subtracting. Wait, let's look at this again. It's 2 to 7 all the way across from 5 to 2. So this is an add line. This here is a subtract line. But now it needs to add this stuff back because it gets subtracted twice, right? From this corner onwards to the right. And this stuff also needs this stuff overlaps with another subtract. So this has been subtracted, and then so this gets subtracted twice, and now that needs to be added back. But those are the only cases. Like, what could cause that to be added to the list? Let's print the new areas that we're subtracting, and see if this is actually one of the full new areas or something else. Line subtract new area. Okay. Okay. 2 to 7 to. Interesting that there are only 3 of these. So how many verticals do we have altogether? Word dot size. We have 7. Oh, 1, 2, 3, 4, 5, 6, 7. Okay, yeah, we subtracted all 3 of these. And those are fine. So 2 to 7 minus 7, sure. 7 to 7. Hmm. So this is a little line. That's weird. These are both 7 to 7. on the X range. Yeah, these are vertical lines. Oh, you know what? That needs to be extended to the right +1 as well. Right? We did that up here. And we did that here too. Mm, let's just do like a +10, whatever. It shouldn't matter, whatever we add there, as long as it's the same. Okay, this should look a little bit better. Okay, 216 along the, but the Y range is 5. Oh, now there are more. Oh wait, yes, that's the more. That's the 2 lines. Um, so these 2 to 16, 7 to 16, 7 to 16. And there are 2 others. So 2 to 16, 17. It's just these 2 at the top. 2 to the end on columns 5 and 2. So or rows 5 and 2. 2, 3, 4, 5. And yeah, so since this gets added twice, so this block here, we take this border, we look to the right, we need to subtract this bit, and we need to subtract this bit. So that's fine. We add this, add this, add this, add this, we subtract this. We should also be subtracting this. And that seems to be missing. We have the 2 lines. It should actually have 3 lines. And then the 3 borders. And the borders have nothing funny going on. Actually, that should result in like more things being added back. Right? So if you subtract from this forward, no, that's fine. That's completely fine. Well, we have to add this onwards back. This onwards back. How many are we adding? Yeah, the stuff that needs to be added back is not there. This is a color scheme an aristocrat to use. This is a color scheme I've chosen because it looks close to adding a code. Right, it has the little yellow and green highlights. So for me, it's a seasonal color scheme. That does look nice. It is called Outrun Night meets Synthwave. I'm swap between these two. Let's go with the dark one for now. Okay. So we need to add things back. So when we're subtracting these 3, we add back here and we add back here because they are double subtracted. So subtract twice to get things, but it's apparently not catching them. So if O dot top equals new area dot top. Oh, wait. Should be like new area dot bot. You know what? I think Copilot tried to autocomplete this for me, and I disagreed with it. Okay. So if it's new area dot bot, sure. And then new area dot bot left. Then new area dot x range. O dot top to O dot top, sure. And now O dot bot equals new area dot top, new area dot top left. And now this here is wrong. O dot top equals new area dot top. Subtract back. Subtract back is this case here, where we've added this block and it's connected to this block that we're subtracting. Add, resubtract, and it's pointing in the opposite direction here. Yeah, so suppose this area went further down this way where my mouse is going. And we've added that. But now this point, oh, hold on. No, that's not quite the case. Anyway, this case shouldn't even trigger here. um, I should still fix it. So if O dot top equals the original, we're adding something, and then new area dot bot. So we have like a stair step thing going on, right? Let me pull up a specific example. No? What kind of new area should be adding? Oh, we have a peninsula going on. So something like this. We're subtracting, we match to the top. Oh no, it should be like if we match opposite. Maybe that case never even really matters. Okay, I'm gonna comment that back out for now. Yeah. And we can think about that when we actually get to that. For now, we're looking at our size, and it's not quite right. What gets added? Where 4 bits are added. And some things get added twice, so that would be subtracted, sure. And when we're subtracting these, here, this gets subtracted. There are bits that get subtracted twice, so we should also have 2 rows in addition to these 4. And those rows are not showing up. That should be the subtract twice call here, right? Oh, hold on. Okay, we are subtracting. And we have an added range. It should be called subtracted twice. Okay, now we're looking at subtracted. Yeah, we're looking at another subtracted range. And they overlap on opposite ends. This is the first thing that should be added to subtracted. Let's print line subtracting new area. So this first one, this 2 to 16. Yeah, that's the first one, 0, 1, 2. Wait a second. It shouldn't start at 2. Huh. AC plus SC dot overlap. Oh, this count might need to be a little bit different. Let's print what we're adding. Our choice of whether we're adding or subtracting. And I think I touched on this earlier and forgot about it. So the choice of when we're adding and subtracting, quite right. Our choice of what we're adding is actually fine. So full range 2 to 0, full range 7 to 5, and then we should have 2 forward and 5 to 2, 2, 3, 4, 5. So this is good. And this one here is wrong. There should be a 1 in here somewhere, right? Oh, we're subtracting. Yeah, this one here should be adding. All right. So the adding overlap doesn't count. They are connected. Yeah, I'm gonna rewrite this a bit. To an extent, it is kind of that. But there is another condition. This is still this be an and. That is necessary but not sufficient. So the area contains bits of my line. And if it's an added area, it's not connected. And horizontal. Line from A dot top left. Is that quite right? I think we want, yeah, top left. I think this always should be line.q on the right side, the right side of the line, because we normalize all these horizontal lines. So not left or top left. Could it possibly both, like technically, but in practice, no. Let's see what we print now. Adding areas. That looks a little bit better. Adding 4 to 16. 0. No, it should be, that was found, this was found. This was not found. The 2 should be found. I have a 0, a 1, and a 2. And the 2 might be being converted to like a subtract. Yeah, okay, we have to fix the subtract parity as well. Oh, we can change this. No, let's just do what autocomplete gives us. Okay, now let's see what we're getting. 0, 1, 4. What would be the vertical range on that? The vertical ranges are generally correct. We have 2, 3, 4, 5, 2 to 5. So where's the 2 to 5 vertical range? Okay, so we're subtracting 5 to 2 by this is a 1. Okay, we just shift it over because we're subtracting. Um, by -1. Why is that being counted as subtracted? It's only because of the count of overlaps. The count of overlaps here would actually be 0. Right, for this line, we'll have a bunch of added. We have 3 added. To only overlap with these two. Do a quick bit here. We do this, we're going to do a quick print line. So what we say, A eventually overlaps with line. Okay. So we add these two ranges and then potentially overlaps the line, and then we're adding this now. And this is during the added count. This one, B16, line 25 to 22. And two things potentially overlap, right? That's an even number. I suppose the negatives, are there any negatives? Yeah, let's say added, whatever. Say subtracted over here. That's potentially overlaps the line. Oh, wait, this is inside of an if. Okay, so 2522 added potentially overlaps. So 2 if there. That's it. It should be 0. We should be adding this, right? Let's add a print line saying what line we're handling. Yeah, it's a little marker. So we're handling 2522. And added. So it's 0, it's even. There's an even number of these. Like for the very first one, we're handling this line, it's 0. Okay. Let's do print line of whatever this is. 5. Or we decide that we're adding a new area. ACSC equals 0. Great. And now, where is that line we're worried about? 2, 5. Here we go. 2, 5 to 2, 2. AC equals 1. So one of these overlapped with it. Wasn't considered to be. Okay, so one should like overlap on the top, the other should overlap on the bottom. Um, Initial check, and this one here. Is there a horizontal line connecting a dot bot left? Oh, my sub's is gonna need to change, by the way. It needs to move. Let's just do it right now. I'm remembering it. S dot west dot S dot bot left dot west. Because that's where the original point was. S dot top left dot west. Okay. Again, AC is 1 here. So, and one of two cases, a dot bot left equals line dot q. Q, hold on, q is the right side of a vertical line. It actually doesn't matter. Wait, no. Oh, wait, there's a P and Q. This line is a vertical line. Yeah, so this would be opposites. We have to make sure these are opposites. Let's normalize our vertical lines too. That way we know which one's the top. Um, we can just add the same sort here. Okay, and now this is like 0.02. All these points are going north. 0.45, 0.65. These are going to the right. And here, my vertical points. Oh, hold on. That hasn't changed anything. We need to do this on y. If p dot y. Okay. Now they're all going south. Y is increasing. Okay. Now we know about p dot q and p dot y. Now, a dot bot left and q dot top, or line dot top, the p. And a dot top left. And wait, hold on. P is a top. Yeah. Top left, q. Okay. Now let's look at that. Or you know what, rather, let's look at what gets added. 0, 1, 2, the two skinny ranges. Oh my god. That's good. Right? 0 to 5, and 7 to. Wait, these are not skinny ranges. This is too many things now. But these first four look right. Okay, let's make our stuff a little bit less noisy. I don't think that anymore. Look at what's being added. Let's take out what line we're handling for now. So adding those areas, these two should also be, these two should be subtracted. So the count is going wrong for those. I think we just need to make a similar change here. Um, so we'll consider it like not overlapping. That's subtracted if it's connected to it on like on opposites. So bot left out west. So bot, our lines go from top to bot. So this should be P. And this top goes with Q, which is bot. Okay. That's almost there. This one here. Let's look at what line that is. Oh, you said electric PLC more. I missed that. Outrun. Oh, yeah. No, that's what we stuck with. I do like that has more contrast with. No, I guess it's just darker. Oh, my little background thing is set up for night instead of electric. So when I turn on the chroma here, fine, I can fix that. Okay, something is not quite right. So which one is, let's do this. Which line is not being handled properly? Line 60 to 65. 0 to 65, where is that? Wait, what? 60 to 65. This is this one all the way on the right. Um, yeah, there are two added points, but those added points are connected. Oh, okay. Yeah, there are two edges. It get a lot more complicated because any set of these points can be um, I should just take like an arbitrary point on this line and just do the normal cast array, do even and odd. We can't really cast array, like cast it when it gets too big. Yeah, so I think it's because there are two added areas to the left of it. Or three added areas, right? This one right here. wait, we add it when this whole thing is even. Let's add this back to, what are we counting for it? Last one here. We have 3 added and 1 subtracted. 3 added overlaps, 1 subtracted overlap. So 1, 2, 3 added overlaps, 1 subtracted overlap. Really, like, I look at this and I say, there's like 1 boundary to its left. We have, oh, this subtracted overlap. Added this. Right, this is like a, I mean, I suppose I could trace this around. And just keep track of our curvature. That is one way to do this. And I can implement that, make that pretty fast. Oh, it is past 4 a.m. though. Okay, I have to go to bed. I have to go to bed. Um, keeping track of curvature might be fine, right? We trace around the edge. Whenever we're facing north, our direction is north. We subtract all the stuff to the right. When we're facing south, we still we add back stuff, right? And when we're facing west or east, it doesn't really matter. And that can help us keep track for each of these. That would work. And I don't know why I didn't start with that, or why I didn't even give that consideration. Is what I have salvageable? How do we know that this is subtracted? In fact, let's just look at the broader example again. Right, like an example like this. Here, we look to the left, and we're like, okay, there's an added line here, a subtracted line here, added line here, added line here. Oh, it's not merely a count of it, is it? I guess we look at the closest one. Yeah, we could look at the closest one and be like, is the closest one to the left? But now, could it possibly be both like an added line and a subtracted line to the left? Yeah, it might not happen, but could be. In which case, how? No, there'd have to be something. There's always going to be something that's. It'll go on for some time. Whatever. You just look at the one that's connected to it, right? You look at any line that's connected to it, and if that was an added line, this is a subtracted line. Done. Yeah, we only count the connected pieces. Oh, but we sort of, I thought we are only counting the connected pieces. So here, like for this last one, this bad case, AC is 3, SC is 1. AC, what would those 3 be? And there's a line. You know, let's just comment this out together. That and in. Just be using key bindings for that. Oh, wait. This is and not. We look at the closer of the two connected lines. And let's say they are both the same distance. Either they're both going up, in which case you only consider the one that goes up and overlaps with it properly. Yeah, you only consider, and if they go in opposite directions, it doesn't matter. If they go in opposite directions, this is the same thing. Okay. Yeah, we can fix this. We can fix this real quick. We're gonna comment this out. So we're just gonna say adding. You look at connected. Like look at if it's added top connection, sure. Add top connected. So added dot find. Hey Alka, how are you? Did you finish? I took an approach. I thought of a better approach, but I still think I could salvage the approach I have here. So I'm deciding whether something is being added or not by looking at what it's connected to and look at what directions those things move in. And this is gonna be like a big old ugly if else, but it's gonna get me through this. So added that find. Or you know what? I'm gonna do like add. Yeah, we gotta do this. So find a dot top left, or rather there's a horizontal line, a dot top left to Oh, zombie shoe. Is it show? Welcome, welcome. Good to have you. Did you get tonight's problem? Yeah, I'm doing part two. And I've thought of an approach that can work well. But I'm already doing another approach. So I think it's salvageable, and I'm trying to salvage it right now. Chow? Zombie chow. Okay. You tired? Yeah, I feel yeah. I feel yeah. We're gonna try this. If we run to other blocks, I might call it a night. Um, but let's see. So there are a few cases here. There are too many cases actually. So like this is a top connection going. I don't think I even care whether. So we're gonna take the union. Val lines equals added union subtracted. The nice thing about this is if it works on the example, or I mean if it works on the on part one, it'll work on part two with the same performance. Because the only thing that changes about part two is sizes, right? Um, okay. Or we'll just call it all the areas. Areas. Oh, val areas equals added areas union subtracted areas. Like I made. You know what? Hold on. The new approach I thought of. I just do it. I think I just do that. I'm wasting time trying to salvage this. Um, make sure we uncomment this stuff. Oh no, not all this stuff. You just make sure that's compiling. And we're not going to use that. Um, so we're just gonna fold left directly on the instructions. Uh, plan. This gives me like a list in order. Direction we're facing does matter. Yeah. Input dot fold left. We can do this. We're gonna keep that 2 cardinal for now. Um, we will start. We will start with a 0, I suppose, and we just need to add areas altogether, right? Or area sizes, right? Not even. You don't need to keep track of anything else. Hmm. Wait, we do need to find like the right side of thing. Boundary points. We have a bounding area. Let's go from here. Once we have the bounding area, and we'll just go through inputs again. Maybe I map this. Maybe I map input. I just need to keep the directions as well. Yeah, I'm gonna map input to directions and numbers. So we have a list of string, right? Yeah, we'll do this separate. We'll just copy paste this in, and we'll only keep distance and direction. And then we'll do with that what we can. I don't think we need to make lines even. Okay. So def parse instruction string direction and int and direction to distance. Okay. And we fold left. We have state here. Input dot left. Point dot origin. I suppose we'll have a direction. We're getting directions from the instructions. So I'm gonna start point dot origin and 0. 0 area so far. But the thing is, okay, if we do this here, we don't necessarily know if this is an in or an out. But if we're wrong, we just reverse it. Yeah, so we have like one side or another side, right? Um, no, input map parse, and then we hold left. So pause, Doug. That's not quite what I would name them. We have the position. Oh yeah, Doug. Exactly. Um, Fine. Doug works. And if maybe we do a match on the direction. Dir match case dir dot east or dir dot west. In this case, we just move on to the next. Deposit move dir, Doug plus distance. We're not going to add the distance. And if it's north or south, then we do have a sort of line. I don't think I care about the line. So let's start by making a new pause val, new pause. I guess we have to do a dy and we can calculate an area. And then we have to keep track of curvature as we are turning. So I suppose we need to keep track of like our current direction as well, or what our previous direction was. Because if we turn left, we're facing north. Right, every time we kind of go like clockwise, if we go west and then south, mm, okay, let's keep track of our like current direction. And then this is going to be like our new direction that we're turning to. And then that's how we can determine which way we're facing. Um, so input 0, we'll parse that. Val starter is one part of that. This returns a direction and an int. I don't know if the start direction actually sort of makes sense. What is this? Yeah, for the first direction, we move east. So let's say like we're not even turning. And this one we'll rename to new direction. Okay, point, how much is Doug? And then we have, I guess it's the direction, not east. We'll just use starter. Yeah. In which case we don't have to worry about east or west, we move on. North or south? Well, depending on the previous, we'll determine if it's inside or outside. Actually, another direction. Let's say, I guess we need to keep track of our date. Like, is the right, let's say, like we start by going north, and we decide the right is inside. And then, wait, every time we're moving north, oh, this is easy. So just like north and south points are always going to be different, no matter what. Yeah, so we just, for north we add, for south we'll subtract. So this start direction doesn't matter. Um, and we'll call this the size or area, like area, I don't know. Okay, oh no, we don't want to shadow our, we call it bounding area. Okay. So we make a new area. So there's a new position. There is a dy, and I guess we have to kind of look. Okay, let's look at our graph. So when we're going north, we remove stuff to the right. Um, there are still these like little overlap rules, and those overlap rules I've sort of solved, right? Sort of solved. Did I solve them? I don't know which part of that solution is actually missing. Like in this case, since there's a boundary above it. Okay, let's say we're going clockwise, counterclockwise. we're heading north, so we're going to delete everything to the right. And now we're heading south. And because we're heading south, we should undelete that. Oh, hold on. If we're going west, wait, what if we go south and then west? So if we go south or east, north and then east. Now that path we took east needs to be um, added back in. In fact, all of this needs to be added back in. So we're going south, and then now we go west. We go south again. So south we're adding. Now there's 2 bits because we've gone from we went southeast south or southwest south. Same thing would have happened, right? Southwest south, and there would be stuff that gets added twice, and we have to delete. So any horizontal between 2 souths needs to be added back in. If we have a south and a west, okay. So we can look at these in like groups of two adjacent south and north movements. Two adjacent south and north movements. And I need to sleep. Oh, I'm sorry. I think I have to call it a night. I think we're onto an idea here. This idea will keep me up in bed. And when I sit down to do this, it'll be fast, because I'll already have thought about it. It'll be like half an hour. Maybe less. So move to, just think about it a little bit. So if we move north and then north, we're deleting to the right. We've over deleted, we add back what's in between them. If we move ever north and then south, and the thing between them needs to be deleted. If we move south and north, right here, south, we add, north we delete, south we add, north we delete. And the thing that's between them, wait, nothing needs to happen in this case. Yada, yada, yada. Yeah. I wonder if we can generalize part of this. So north and then south, this thing is happening. Left on the south, right? We're moving south. We're gonna add. Oh no, hold on. We move north. We should delete from like one later, right? Yeah, we move north. We should delete from one later. We take a west. That west is gonna have been deleted. I think whether it's east or west. Let's say we go north and then east. It isn't east, and we do want to delete all the way up there. Okay, that will take thinking. I think that's the approach I'll try tomorrow. Let's do a raid. Is anyone still doing admin code? Voter 2K. 1 uptime. I think I remember 1 uptime. Oh yeah, I do like a lot of Java code. Okay, this is
Wird das dann
German.
negativ?
Let's join one uptime. Okay, good night. Good night, everyone. Thanks for stopping by. I'm gonna log on maybe like an hour early to finish this tomorrow. Or maybe in the afternoon. We'll see. We'll see. So, raid one. Thank you. Thank you.